Sorry, do you hear me?
Yes.
Okay, so I'm glad to see all of you are here, and I hope all of you stay healthy. So we begin the section of information technologies of USBEREIT 2021 conference, and we start the first section, which will consist of 5 presentations. And you can ask a question in the Zoom chat, and also there is an options for questions in our YouTube broadcasting. So if there will be questions in YouTube, I will read it after the presentation finished. So each presenter have 10 minutes for presentation and 5 minutes for question answering section. If everything clear, we can start. And we start with the presentation of Andrei Sheka, rotation augmentation for head pose estimation. Andrei, are you ready?
Yes, can you give permission?
Okay,
Sharing?
sorry. So try, please.
You can see presentation?
Yes, we see. You can start.
Okay. Rotation augmentation for head pose estimation problem. Head pose estimation problem solve the task of prediction pose vector for same image. These angles are roll, pitch, and yaw. As you know, data augmentation can increase data representativeness of training data, and but as you know, that rotation augmentation can is well known for the detection problem, but the rotation augmentation hasn't not been used before the head pose estimation problem, because it needs to recalculate some angles. And in this research, we make such operation. In this slide, we present recalculating of bounding boxes in rotation augmentation. This is general method for bounding box. In this slide, we show how we can recalculate head pose angles. First, we have alpha, beta, gamma, pitch, yaw, and roll respectively, and calculate a rotation matrix. Then we calculate new rotation matrix by using this formula, and the final we calculate new alpha, beta, gamma, such formula form. In this slide, you can see how it works on sample. Recalculating bounding box include rotated bounding box, and we can grant that face contains that bounding box include face. For testing our augmentation, we use default experiment protocol using for head pulse estimation. As training dataset use 300 WLP and as a test dataset we use FLV 2000. As we use naive approach, as backbone we use pre-trained ResNet 15 regression via classification with bin size equal to 1 was used for each angle, and other details experiment you can see on the slide. We just use only horizontal flint and rotation for augmentation, and we check a different rotation angle for augmentation. In this slide, you can see results of experiments with different with various rotation on test dataset. As can you see, we have good results for 14 degrees. We comparisons with state of the art result, we reach nearest state of the art result of multi-head neural network before several points. As a result, we can use naive approach, just naive approach with regression via classification and ResNet 50 with pre-trained weights. But other neural network in state of the art use some special architecture, and they very complex. But we just use very simple approach. Thank you for attention. Do you have questions?
Yes, I have a few. So, Andrei, could you please describe what you mean by regression via classification? So it's a bit not clear for me.
Regression via classification we use when we create, for example, if you need to predict some values from 0 to 10, you can make head with just regression, or you can create classification with 10 classes for 0, for 1 value, for 2, 3, so on. And when you predict some value, you just summarize. You get weight sum of classes. For example, you have 10% for class 1. It means 1 value of 19 degrees for value 2, and you just got calculate weight sum.
Okay. Yeah. And also question about slide. Can you switch to slide number 9? Yes, and can you please describe what means improvement of MAE? So,
Improvement, it is with baseline.
so what
It's
is baseline?
baseline. It is just a horizontal flip augmentation without rotation.
Okay. Any questions? Mhm. And the question from the YouTube translation. So, how significant is your work in the context of current research in this field? Thank you for a good presentation. From
Can
Kirill
you
Zeide.
repeat?
How significant is your work in the context of current research in this field? Thank you for good presentation. Question from Kirill Zeide.
We the main result that we can use just simple augmentation and achieve result near state of the art.
Near state of the art.
Because other works use very complex neural networks with complex training. For example, last work, multi-head neural network, they use additional data set for landmarks predictions and auto-encoding architecture. But we just use a naive approach.
Okay, so you mean that you have performance like state of the art, but you do not need such, huge neural networks with millions of
Yes,
parameters.
and
Yes.
complex train framework.
Okay, so it's clear. Any questions? By the way, thank you for quite short presentation. So we have some additional time. So once again, any questions? If there is no questions, so we can switch to another presenter, which is Garnik Variljan, with a presentation Anomaly Detection in Image Dataset using Convolutional Neural Networks, Center Loss, and Mahalanobis Distance. So Garnik, can you please?
Yes, I'm here.
Okay.
Good day, colleges. My name is Garnik Variljan. I am a student of Perm State University, and I will tell you about anomaly detection in image dataset using convolutional neural networks, central loss, and Mahalanobis distance. User activities generate a significant number of poor quality or irrelevant data that can be processed in the main data processing pipeline or included in the training dataset. Such samples can be found with manual analysis by an expert or with an anomaly detection algorithm. There are several formal definitions for anomalous samples, but for neural networks, the anomaly is usually defined as out-of-distribution samples. And we propose two methods for supervised and semi-supervised detection of out-of-distribution samples in image datasets. Both of methods are based on the analysis of deep feature vector space of neural network classifier. The first, supervised approach, is based on the second hand that analyze deep features. The second, semi-supervised approach, is based on the usage of the central loss and usage of Mahalanobis distance. In case of anomaly detection, supervised approach requires labeled data, both normal and anomalous data. Semi-supervised approach requires only normal data. We propose two methods extending convolutional neural network for image classification problem. The image at the top shows the typical scheme of neural network classifier. The last hidden layer of that neural network provides us a deep feature vector, and the analysis of distribution of deep feature vectors allow us to detect anomalies. The extended networks solve classification and anomaly detection problems at the same time. The first semi-supervised auto-distribution detection method complements cross-entropy loss with central loss. Training of neural network for classification problem is performed with the main training set. Training with the central loss provides us deep feature space where samples are grouped around proper centroids. The image shows the visualization of a post method. After the training, we pass all samples to the neural network. This way, generate deep features vector where each vector belongs to one given class. The next step is computing mean vectors and covariate matrix for each class. And now we can compute Mahalanobis distance between deep feature vector and set of deep feature vectors of each classes. After that, we choose the threshold that separate normal and anomalous data. As the image, they marked as eta. In our experiments, we choose threshold as 97.5% percentile. If the deep feature vector of new image is located closer to any target classes than their threshold, then we marked this image as normal data. Else we mark new image as anomaly. The second supervised auto-distribution detection method also use the central loss, but analysis of the deep feature vectors are performed with the multi-layer perceptron. Training of the neural network is performed in two stages. In the first stage, we train on the main dataset. In the second stage, we train the second head of the neural network for auto-distribution detection. In the second stage, weights of the main network are frozen. The second head is trained on the samples from normal and anomalous datasets. We used MNIST and fashion MNIST datasets to train DNet5 and 3 splits of ImageNet 30 dataset to train EfficientNet B0. EfficientNet 30 is a dataset of real-world objects, and it's a subset of the dataset ImageNet. The first thing to say is that central loss don't disapprove the performance of neural network in the classification problem. Central loss improved results in 4 out of 5 series of experiments, but generally, usage of central loss affects the image classification performance insignificantly. In case of using Mahalanobis distance to auto-distribution detection, central loss improved the F1 score in all 5 experiment series. And according to ranges of F1 scores, the optimal value of the balancing coefficient lambda is 1/10 or 1. In case of using multi-layer perceptron for auto-distribution detection, the central loss didn't affect the F1 score in experiments with Linet and MNIST, but central loss significantly reduced auto-distribution performance in experiments with real-world object and deeper neural networks. It means that using central loss in case of multi-layer perceptron is not justified. Central loss and Mahalanobis distance is suitable for the semi-supervised methods, but central loss can bring advantages in supervised auto-distribution detection. The semi-supervised method is more early because it doesn't require a dataset with anomaly samples for training. However, supervised approach is strongly depends on the choice of proper anomalous dataset. Increasing the balancing coefficient lambda improves the accuracy and area under the raw curve for auto-distribution detection in case of semi-supervised approach. In our results, the supervised method has proved itself to be more accurate in comparison with semi-supervised method, and that makes it favorable for real application. Thanks for your attention. If you have any question, I'm ready to answer.
Thank you, Garnik. I have a question. Can you please describe in more detail what is balancing coefficient lambda? It's not clear for me.
It's a coefficient. It's a weight of central loss in general loss function. You can see it on equation on the slide.
So it affects on the difference between X and C, which is...
Yes.
Okay. Any questions from the participants of the conference? Okay, Garnik, thank you. And we move to the next presentation. Rafael Blankson. Are you there? A presentation applying variational circuits in deep learning. Our presenter is here. Okay. Maybe Mikhail Gashnikov. Are you ready?
Yes, I'm ready.
Okay. You can start your presentation.
Just a moment.
Okay. Take your time.
Hello, dear colleagues. My name is Mikhail Gashnikov. Do you see my presentation?
Yes, you can start.
Excuse me for my bad English. The topic of my research, increasing the size of the camouflage area for remote sensing images. Image camouflaging is a replacement of an image path with an imitation. We clear some area in the image, and then we use image painting algorithms to fill this empty area. You can see examples of remote sensing images with empty areas in the first column. And the results of image painting algorithms are located in the other three columns. we can use image painting to solve various problems, for example, 4G generation and image camouflage. The structure of our presentation is as follows. First, we briefly consider common approaches to image camouflage. Then we describe in more detail the exemplar-based approach. And we consider generative adversarial network based on contour prediction. And then we present the results of computational experiments. We divide approaches to image camouflage into neural network-based approaches and traditional approaches. The first of the traditional approach is based on the so-called sparse representations. This approach uses the representation of an image fragment through a linear combination of specialized basis functions determined by the analysis image itself. The next well-known traditional approach is the diffuse approach. This approach uses partial differential equations to propagate information to the image area. The most powerful traditional approach to image painting is the exemplar-based approach. We compare exemplar-based approach and the approach based on GAN. Consider in more detail the exemplar-based approach to image camouflage. Exemplar-based algorithms use fragments of the processed image to fill in empty areas. The algorithm searches for fragments that are similar to fragments located near the filled empty area. The algorithm fills the empty area iteratively, and this area decreases gradually. There are results of the exemplar-based algorithm. Hello. Hello, excuse me. The results of the exemplar-based algorithm can be quite good if the algorithm finds a good fragment to fill the empty area. Therefore, we use this algorithm as a basis for comparison with more sophisticated image camouflaging algorithm. So it is the base for comparing to GAN. At present, generative adversarial networks, GAN, have the best results in the image camouflaging problem. Generative adversarial networks are based on competition between two naked neural networks, a generator and a discriminator. The generator creates fakes, and the discriminator distinguishes them from natural data from some unmarked dataset. The task of the discriminator is to detect fakes as best as possible. The generator has the inverse task to deceive the generator. In this paper, we investigate the generative adversarial network Edge Connect based on contour prediction. Naziri proposed this neural network in 2019. This neural network uses a two-stage model, which includes two series connected subnets, contour predictor and area in painter. Both the contour predictor and the area in painter are generative adversarial networks. We suppose that the specialized contour generation algorithm is capable of improving the effectiveness of remote sensing image camouflage. We tested this assumption experimentally. We performed computational experiments to study the effectiveness of considered generative adversarial network with the contour predictor for inpatting of natural remote sensing images. As a basis for comparison, we used the considered exemplar-based algorithm. We used publicly available images obtained by resource Canopus ICE Meteor aircraft, as well as good Earth images. Here you can see results for Meteor aircraft. An important issue in the camouflaging algorithm effectiveness is camouflaging large areas. Often algorithms that perform well on small or narrow areas noticeably lose their effectiveness when trying to camouflage larger areas. We deal with the effect of the camouflaged area size on the quality on the camouflaged image. So we camouflaged the remote sensing images with the studied adversarial neural network inside areas of 3 different sizes. We displayed the contour of these areas in red. You can see that generative adversarial network with the contour prediction demonstrates the high quality of remote sensing in painting for all sizes of camouflage area. GAN results are much better than the results of the exemplar-based algorithms. This GAN will camouflage long objects with gaps. Here you can see a river. Further, you will see roads and buildings edges. And the exemplar-based algorithm often fills gap with textures from night-boring areas. So gaps are filled incorrect. There are some results for a higher resolution image of iced aircraft. You can see that the generative adversarial network with the contour prediction provides high quality of square area camouflaging. GAN fills such areas with natural textures or parts of objects. The exemplar-based algorithm often fills such areas with a uniform texture or selects an unsuccessful fragment for them. You can see that there the exemplar-based algorithm places the road inside the houses, inside the buildings. There are the results of Canopus aircraft. You can see that remote sensing images remain sharp after the generative adversarial network. Images are often blurry after the exemplar-based algorithm. There are the results of resource aircraft. You can see that large camouflaged GAN areas are usually difficult to detect. The camouflaged areas of exemplar-based algorithm are often easily visible. Here we place the camouflaged areas of different sizes on the same image. You can see that the generative adversarial network demonstrates robust results. The quality of the output images is high and the quality varies slightly from image to image. The quality of the exemplar-based algorithm is greatly significantly in many images because the algorithm can select a successful fragment. Look here at the road inside the building on the right image. Here you can see that the quality of GAN is almost not reduced with the increasing size of the empty area. the quality of the exemplar-based algorithm is noticeably worse for the second and especially the third area. As a numerical measure of the camouflage quality, we used an estimation of the sharpness of the camouflage area, since the decrease in this characteristic is especially noticeable when camouflaging. The numerical measure of the sharpness was the averaged local gradient length. We consider the relative reduction delta in the sharpness of the camouflage area relative to the sharpness of the unprocessed area. We use this value as a measure of camouflage quality degradation. You can see that the results of the adversarial neural network are much better than results of the exemplar-based algorithm. So we investigated generative adversarial networks for remote sensing image camouflaging. We experimentally proved efficiency of this gun with an increase in the size of the camouflaged areas. Thank you for attention. I will try to answer your questions.
Thanks, Mikhail. I have a question about exemplar-based approach. So can you please describe how it finds the most appropriate part to fill the image? So you said that exemplar-based approach filling the camouflage area with some parts of neighborhood images. Yes?
Yes, I will try to explain. The exemplar-based algorithm use the nearest neighbor field, NNF. Each element of this field contains the offset between the source fragment and at the point tau, and a similar fragment found at another point. We initialize the nearest neighbor field with random numbers or a priori information. Then the algorithm iteratively performs the propagation step and random search step to improve the nearest neighbor field. At the propagation step, the algorithm propagates the NNF element to neighboring elements if the error between the source and the found fragments decreases for these neighboring elements. At the random search step, the algorithm is looking for the best fragment among candidates who have an exponentially decreases offset from the source fragment. Usually 3 or 5 iterations are enough to get a good result.
Okay, and another one questions. You tried only masks in the form of X and just a line. Can you please switch?
Yes. We used 2 forms of the masks, and we used 3 sizes of this mask.
Okay, so the first, why you should, so sorry, why you use only this form of masks, and does it affect the quality if the form of mask will be another shape?
I think these forms are enough. We can see what we can see all effects. The cross mask have an area in the center. This area have relatively big size, and the main task of our research is the effect of the mask size. We researched the effect of mask size, but we don't study the effect of mask form.
Okay, I understand. Any other questions from the auditorium? So if there are no questions, we switch to our next presenter, Yulia Timoshenkova, with presentation about influence of weight initialization algorithm on accuracy of the forecast with LSTM-net for harmonic signals. Yulia, are you ready?
I am ready.
Okay, you can start.
Mikhail, can stop translation?
I try. I found the button.
Okay. Do you see my presentation?
Yes, okay, you can start.
Hello, I am Yulia Timoshenkova. I will present the work about influence of weight initialization algorithm of accuracy of the forecast with LSTM-net for harmonic signals. A lot of dynamic processes of human activity are described by data set, also called the time series. Forecasting this time series is a complex and actual modern problem. Today, there is no universal one to provide the required accuracy. Traditional artificial neural networks do not have a memory. For different time points, input and output are independent. For no stationary problems where characteristics of system change with time, this cannot work. One way to solve this problem is use the long short-term memory network, also called LSTM. It's specifically designed to estimate long-term dependence. There are two known approaches to initialize the weight matrices. The first technique uses a weight matrix consisting of zeros, ones, and other natural number. The second approach uses random number generated according to distribution. And also, you can use the orthogonal matrix or various scaling methods. This issue is rarely discussed in scientific works. Thus, the study about the influence of weight initialization algorithms on accuracy of the forecast with LSTM-net for time series is important. The article investigates the forecast accuracy for model time series with time-ordered samples of harmonic and modulated signals. In our research, model time series have been studied in form of harmonic signals, amplitude-modulated signals, frequency-modulated signals, and also we use the amplitude-modulated signal time series according to the following procedure. Decimation of the amplitude modulation time series with decimation coefficient equal 4, reconstruction of the decimate time series at the nodes of the time grid using fifth-degree polynomial. The value of the time series obviously differs from amplitude-modulated data, but the mode of the used interpolation method error. The signals are shown on the slide. These functions have been chosen due to the fact that they are widely used as basic models in the analysis of real-time series. In research, we used two-type training and test set. Each time series for signals have been divided into training and test set. First data was 480 training samples and 32 test samples. Second data was 448 samples, training samples, and 64 test samples. On slide present all LSTM weight which we used in research. First three weights use random number with uniform, normal, or truncate normal distribution. Zeros and ones weights use zeros and ones matrix. Got normal and got uniform also called except normal or uniform initializer, identity weight use diagonal identity matrix, orthogonal weight use random orthogonal matrix, constant weight use matrix where each element is equal to the select natural number, and various scaling samples are drawn from a truncate, untruncate normal distribution with a mean of 0 and a standard deviation. In research, we use multi-step forecast technique. On slide present schema of this technique. Multi-step forecasting, another approach where the real observations are unavailable for some time, and the forecast can only rely on the previous forecasted observation. This technique is more complex and requires from a last-time net much more accurate initial estimation. But only with this type of the forecast, one can freely estimate the possible limits of recurrent neural network memory structure. To the research, use the following sequence of action. First, we make training a test set. Next, we has following parameters of neural network. Number of neurons is 2056, number of learning equal 50, size of input vector is 10, which is equal to the forecast base. The Adams learning rate optimization algorithm is used. The last time net which each of the present methods of initializing the sets of weights. Next, we make forecast using multi-step technique. And in the end, we calculate error of forecast using function mean square error. They calculate mean square error values for each of weight initialization method of LSTM-net are present in the tables. First slide shows result of the first test and training set, and next slide, I click lately, shows results for second test and training set. The highest forecast accuracy for all signals is achieved when the various scaling method is used to initialize the initial weight of the LSTM net. The large forecast error is obtained when I used random normal, random uniform, or random truncate normal weights. The highest forecast accuracy is achieved for harmonic signals and the lowest forecast accuracy for frequency modulation signals. Mean square error is an integral indicator that cannot represent the dependency through time steps. We estimated the value of difference between the exact and corresponding forecast value. This dependence is present on slide. This dependence, contrary to expectation, do not monotonically increase. Instead, they are a combination of semi-periodic function host time series frequency characteristic are similar to the characteristic of the forecast time series. The discovered future or the predicted value using LSTM-net should be taken into account when assessing the forecast accuracy and interpreting the forecast results. In the conclusion, I show results. The obtained results indicate the major influence of the weight initialization method on the forecast accuracy. In particular, the maximum forecast accuracy of the study's time series has been achieved using parallel scaling methods. The best overall forecast accuracy achieved, obviously, for the harmonic signals time series. The value of difference between the exact and corresponding forecast value I estimate, providing that these dependents are some combination of semi-periodic functions whose time frequency characteristic are similar to the characteristic of the forecast time series. And in the end, it is concluded that the long-term forecast of the time series, it is recommended to take into account the present properties of the forecast obtained using the LSTM-net. In the future, other forecast method and correction algorithm for time series analysis would be tested. Thank you for your attention.
Okay, Yulia, thanks. And can you please switch to the slide number 11? So can you please describe where the initial and where the predicted signals? So I do not understand.
It's not initial and predicted signals. It is between 1 minute.
Mm-hmm.
difference between true signals and forecast when we take
Okay.
from experiment.
And so you are tested. Sorry. Do you try another approaches, for instance, Facebook profit library to predict signals and compare it with your approach?
Now I research recurrent neural network, LSTM neural network, and other foremost methods for forecast time series. And today I research correction methods, for example, data simulation. But maybe in future I'm also using Facebook bibliotheques for my forecast time series. But on Facebook, the light did not converge like a wedge.
Okay. So another questions from the attendees. Okay, Yulia. Okay, sorry, my mic was turned off. So there is no presenter for the applying variational circuits for the deep learning, and the next presenter will be in 12:30 according to the Ekaterinburg time. So it is in 40 minutes. There will be keynote presentation for computational humor by Pavel Braslavsky. So there is a 40 minutes coffee break. So see you in 12:30 according to the Ekaterinburg time. Okay, coffee break.
Hello, Pavel.
Mikhail, should we start?
Sorry?
Should we start?
Yes, we can start in a couple of minutes. So, dear conference participants, we are approaching to our first keynote presentation, which will be made by Pavel Braslavsky. He is a senior researcher in the Ural Federal University, and his interesting and fruitful talk will be about computational humor. So, Pavel, if you
I need one. Sorry, I need 1 minute to answer a call. Sorry.
Sure, take your time.
Sorry. Okay, sorry. I'm ready to start. So, hi everybody. My name is Braslavsky. Mikhail, thank you very much for introduction, and thank you very much for inviting me. I will give a very short overview of computational humor. A couple of words about myself. I have actually two academic positions now at Ural Federal University, Yekaterinburg, at Higher School of Economics in Moscow. I have also some industrial experience at Yandex and SKB Contour. And my recent research interests are question answering, fiction analysis, literary work analysis, and computational humor. And if you're interested in my work, you can look at the homepage. There are all my publications with full text. And also my email, if you want to contact me. So I would like to start with a quotation from The Moon is the Harsh Mistress, science fiction novel by Robert Heinlein. And the novel is about one of the lines in the novel is that the main character Manny discovers that the supercomputer that operates almost all infrastructure on the moon achieved some kind of self-awareness, and the sign that the computer entered a new level of consciousness is that the computer developed a kind of sense of humor. I think it's very very interesting point when the computer gets this sense of humor. It means that it has a kind of self-consciousness or self-awareness. So, and in more realistic scenario, I think it's this is another quotation from a paper by West and Horvitz from I guess Microsoft Research, and they point to the fact that humor is a very interesting research area, and if our goal is to develop a machine that will be able to communicate with humans and they will be indistinguishable from humans, we need to implement somehow sense of humor, because we cannot imagine human-to-human communication without humor. So it's very important, also a very important practical point. And actually, it happens already. This is a quotation from an interview by Rahit Prasad, the head scientist of Amazon Alexa, and he's commenting here on the second, I think, on the second edition of the Alexa Prize competition, and now I think the third Alexa Prize competition is running, but it was about 1 year and a couple of months ago, and he was saying that the humor is, and so the Alexa Prize competition is works as follows. Research teams develop a social bots who can interact with people for at least 20 minutes, and this interaction must be enjoyable, funny, and acceptable for people. And you can see that Rahid Prasad says that humor is these social bots already have some kind of sense of humor, and it is again a very good sign for development of artificial intelligence and of dialogue systems in particular. And of course, the main drivers in computational humor research now are personal assistants, voice assistants. I showed some of them here, like Apple Siri, Amazon Alexa, or Google. It was Google now. I don't know, Google Assistant maybe. I don't know the market name of the system. But of course, these devices, these systems must first recognize when humans make jokes, and on the other hand, it would be expected that these personal assistants could also produce humor, so make jokes by themselves. So in my short overview, I will cover some main directions in humor, computational humor research, in particular humor detection, available human data sets, humor generation, and humor evaluation. So let's start with human detection. The task is quite simple, can be simply formulated. You have a piece of text, but yeah, it's important disclaimer. What I'm talking about only on textual linguistic humor, because in some cases you can imagine funny pictures or funny videos, and it's also an interesting research direction. But I'm talking about only about linguistic textual humor. So the task is, if you have a short piece of text, the task of the classifier is to determine if the text is funny or not. And the pioneering study was from 2005 by Mihaltsev and Straparava, and the very important step what they created a data set. A data set had two parts, funny part and non-funny part, and it contained 16,000 one-liner jokes and 16,000 non-funny sentences. And the non-funny sentences come from different sources, like British National Corpus, news headlines, and also collections of proverbs. And they try to, in their study, they try to model them some noun humor features like alliteration, rhyme, antonymy, adult slang, and so on. And they, it was 2005, they employed kind of traditional classifiers like naive Bayes and support vector machines. And you can see here on the results, they achieved quite good results in terms of accuracy. And in some cases, you can see that even simple method can achieve, at least in this data set, at least in this subset of these news headlines, they can achieve quite a high quality results. The next significant work in this area is humor. Actually, the paper has a longer title, but the most important keywords are humor anchors. It's a paper by Young and co-authors from Carnegie Mellon University. And they also introduce a new data set in addition to the known one, this old one, existing one. And they also collected a data set from Pan of the Day. And again, they tried to model some humor-specific features, and they performed this feature engineering step. But they also employed, because it was 2015, they also employed word embeddings. And as you can see from this table with the results, if you look at the maybe how they implemented these word-to-vec embeddings, how they used them for the task. They introduced these humor-specific features, and for example, incongruity. They modeled the incongruity using word-to-vec embeddings, and as far as I remember, they for each joke and non-joke, they calculated the difference between most distant vectors from this short text. It means if the words are very far away from each other in semantic space, it can signal kind of incongruity. So, and you can see that already only word-to-vec features already give kind of high results. And when they combine these word-to-vec features with humor-specific, humor-centered features, this HCF stands for humor-specific features, they achieved even better results. But actually, you can see that the difference in many cases is not that huge. The word-to-vec embeddings provide a much better representation than carefully engineered humor-centered features. So, and as expected, later transformer architecture was applied to the same task, to humor detection problem. Here you can see it's the short paper by Weller and Seppi from 2019, and you can see that accuracy and precision was quite high in case of this standard one-liners data set, and they also made use of larger data set from Reddit, not larger, sorry, it was 14,000. But what was also interesting that they collected these jokes from humor subreddit, from social network Reddit, but and later they annotated the jokes on crowdsourcing platform, and actually there was a quite large margin between what they collected humor evaluation from Reddit, like thumbs up, stars, and so on, and what they collected from Mechanical Turk workers. It means that in some cases, humor evaluation can be challenging, and we will tackle this problem I will tackle the problem at the end of my talk. So the idea is that Reddit community members evaluate joke quite differently compared to how mechanical crowdsource workers did. So to the date, there are several data sets and evaluation campaigns that produced annotated data sets. For example, in 2017, there was a task at Semmelweis, and it was detection and interpretation of English puns. and there were two types of puns in the data, and there were 3 tasks, and these tasks are each next task is more complex than the previous one. The simplest formulation is just a binary classification of short pieces of text, if it contains a pun or doesn't contain pun. Pun location is the task of locating the word that make this text a pun. So mostly either it's a word with several meanings, with several senses, or a word that has a similarly sounding word that can appear in the context. And pun interpretation is the task was to indicate, not just allocate the word, but also indicate the word net senses of this punning word. What actually makes the pun funny? Why? What is the pair of the sentence? What is the pair of the senses of the word that make the text funny? Actually, the participation was not very high, but in 3 years, a new humor-related task was introduced, and it was much more popular. And the task was to estimate the funniness of headlines. In this case, not just binary classification, but it's rather a regression problem. And the second formulation is the pair-based comparison of headlines, and means for each pair, the system has to decide which of them is more funnier, which is less funnier. And it used the data that was created using crowdsourcing when Mechanical Turk workers had to transform a news headline into a funny headline. So here's a summary of data sets that are available to date. I skip it just to be aware that are a bunch of data sets that are already available, and if you are interested in the task, you can just start with existing data sets. And this is a Russian data set. All the data set on the previous slide were in English, but this is work with my colleagues, with my students from 2019. We created the data sets for in Russian for humor research, and it's quite big. It's in total there are more than 300,000 items, and about 1/2 of them are funny, presumably funny, and 1/2 of them is presumably serious or not that funny. So here's a link. You can look at the data if you are interested in the task. A much more harder task is humor generation. So there again, a pioneering work was by Stokas Straparava, and so it's very hard to, I think even for humans, it's very hard to generate jokes from scratch without any structure or some preliminary some considerations. And this system, Hahacronym, generates funny substitutions for existing abbreviations, for existing acronyms. So here are some examples. For example, this is original Association for Computing Machinery, and here the funny variant. And they used a rather simple set of rules, and they heavily used WordNet for example, antonyms, or for semantic domains, and so it's again it not just any kind of humor, any kind of jokes. It's a very specific kind of these funny variants for existing on new acronyms. Here's another attempt to generate humor using computers, and this study, they made use of existing corpus of short messages, and they relied on word substitutions, and they introduced some lexical constraint, like they substituted word by similarly sounding or similarly spelled words, but the same from the same part of speech. They also substitute taboo words with words with taboo words, and they also introduce some rules, like they substituted text toward the end of the sentence and try to keep the new generated the new text coherent using something like language models. And they evaluated it using crowdsourcing on 5-point scale. And here you can see that all the constraints, that all three constraints produce quite funny text. Again, the computer doesn't generate jokes from scratch. It just substitutes some words in the existing human text, and it becomes funny. Here are some examples, and more modern approaches using neural networks. And this idea, it's sequence to pun. It's the paper calls neural approach to pun generation. And the idea is quite, again, I think it's quite simple. First, they using word sentence disambiguation, they marked all the ambiguous words with specific markers. For example, you can see that in some cases there is the same word count, but they added a marker that it's a specific sense of a word. Then they trained a recurrent network based on this data, and at the end, at the generation point, they generated first the left context starting from this word with a specific marker. Then they changed the words to this to the same word with another sense tag, and generated right context. The idea is they are trying to generate text that is ambiguous, and in this case, two words the same word with different senses can produce humorous effect. And another attempt is pun generation with surprise. The idea is somewhat similar, but they make more. It's not that there are more restrictions. The idea is they start with the pairs of similar sounding words, then retrieve from a large corpus a sentence containing one of the words, then substitute the words to its counterpart, to its similar sounding word, and slightly adjust context to the new word. And here's an example. For example, here's a word pair here and here, and here the retrieved sentence. Then they change the word, and they adjust the context to make it more coherent to the word that wasn't inserted. So, and this is another approach. As I said, it's quite tough to be able to automatically generate humor, but there are some research and there are some preliminary results. We also tried, me and my students also tried to work in this area, but we implemented a much simpler approach. We didn't generate any new jokes. That we tried to, we addressed the generation of a funny response in a dialogue setting. And we said we will not generate a new response. We will try to pick a funny sentence from a large collection of presumably funny sentences, and we collected about 300,000 presumably funny tweets, and we experimented with some simple information retrieval models like BM25 or Dr. And here are some examples. We also evaluated the results using in the lab settings, and sometimes it's quite funny because here's a question, and here is a tweet that we retrieved from a large collection of tweets, and it was evaluated by 3 assessors, like quite funny. But in many cases, it's just we can find something that has common overlapping words like allergic, but it doesn't fit the context and it's not funny. And during this experiment, we realized that we don't have a reliable tool, reliable procedure to evaluate how well we are doing, how good are the results. So we addressed the problem of humor evaluation, and we collected, in this case, a small collection of dialect jokes. It's a 2-turn jokes. There's a stimulus and response, and from different sources, including pairs that were produced in the previous study automatically. Here are these automatically generated pairs, and here are some examples. And then we had this is evaluation interface, and we had quite a large group of people on social networks and on Mechanical Turk. And the goal was to understand if we can get reliable results of humor generation, because many colleagues, when we discussed the results of the previous study, were skeptical about humor evaluation, because many people think that humor is very subjective, and cultural background or even gender can influence the evaluation. And the very short results are we can rely on crowdsourced evaluation of jokes, but there are some specifics. For example, some demographic characteristics like age, and in some cases gender and language proficiency can influence perception of jokes. And what was interesting, in some cases we just confirmed previous results from psychological literature dedicated to humor, but in some cases it was not that straight, because, for example, in many, at least in several publications, in several papers on humor perception, the author stated that language proficiency is very important to understanding humor, and people with low language proficiency tend to perceive less jokes and perceive them as less funny. We get an opposite picture. The lower the language proficiency, the higher is the average scores of the jokes. Here you can see that here the average score of the 30 jokes decreases with the lower when the language proficiency increases. Sorry. So I think I'm out of time now, and now we can hopefully we can have time for a couple of questions. Thank you very much for your attention.
Thank you, Pavel, for a very interesting presentation. And yes, we have plenty of time for questions. So you mentioned in one of the first slides that the first data set was around 160,000 of jokes. Yes?
No, it was 16,000 jokes.
Sorry, 16,000 of jokes. But it's still a rather big number. So can you please describe where such jokes was mined? Was generated by the people just specifically for the data set, or what?
Just a moment. The data set just was this so-called one-liners, 16,000 one-liners data set. They collected these one-liners from a website.
Mm-hmm.
And they collected the counterpart, the serious part, from various sources like news, British National Corpus, and collections of proverbs. They automatically collected these jokes from a specific site, and the hard thing was that they wanted the counterpart, the serious part, to be not lexically diverse from the funny part, because if we have some specific words that are used exclusively in jokes, the task of humor detection is trivial. You just look at the words, and if it's a humorous word, you just classify it as humor. And actually, this is, you can see that back of words in some cases actually works not perfect, but it's not hopeless. It means that there are just words specific for each of the class, of the category. So, and actually we tried to do the same when we when we compiled the Russian data set. We tried to make these two parts, two categories of the data set lexically similar to each other, to make the classification problem harder, and to make So the goal is that the classifiers actually classify on some humorous features, not on just on lexical features. But again, as I said, there are already a bunch of data sets available. They vary in the sites, in principles that behind them, but you have also already you have the choice when you are working on this task.
Okay, thanks. And we have another question from the Vyacheslav Filimonov. Okay, you can ask.
Thank you. It is very interesting to me, and I have too much questions, but I ask you only one personal question, and may I ask in Russian?
Sure.
Хорошо. Неделю назад я посмотрел на вашем сайте публикации и написал вам письмо. Вы его не получали или вы не хотите отвечать? Вы можете не отвечать на мой вопрос.
Нет, я его получил, но там не было вопроса. Вы написали, что вы послушаете презентацию, может быть, появятся новые вопросы.
Хорошо, спасибо. Значит, вопросы действительно есть, но я их тогда напишу в письме. Все,
да, конечно.
Конечно.
Okay, maybe another question. So I have another one, and also you mentioned that there is much difference in humor assessing between users of Mechanical Turk and users of Reddit. Yes.
Yes, this is the results from Weller and Seppi study, and they collected jokes from Reddit subreddit, sorry, humor subreddit, and they also collected some some thumbs up for the jokes and try to separate very funny jokes from less funny jokes. And then they also annotated the very same jokes on Mechanical Turk, and it turned out that the evaluation, the annotation from crowdsourcing workers is quite different from Reddit users, community members.
Yes. So my question is, did them track? You mentioned about cultural backgrounds, age, etc., country of living. So maybe we can, generate some another features about human assessing by the different class of assessors.
No, so far as I remember, they didn't perform such fine-grained analysis. But I think I can assume that it's not like cultural difference seen globally. I think most of the users are from the US, and I think they required that Mechanical Turk workers are English native speakers. So I think it's just it depends on the community, and I think it's probably it's a higher level problem, and at the current point we need to solve a much simpler problem. We have to distinguish like funny and non-funny text, and it's much easier than to distinguish very funny and less funny text. And I think it will be the agreement will be much higher in case of different tasks like funny, not funny. What we saw in our study using Mechanical Turk, we had a very diverse community of annotators, and we have in each group we have different English English proficiency levels, and we have different genders, we have different age groups, and so on. So even using such a diverse community of annotators, we could get quite reliable annotations for simple jokes.
Okay. Another questions? Okay, there are no questions for you, and Pavel, thank you again for your very fruitful keynote talk. And
thank you very much. Thank you. Bye bye.
Bye bye. So the next session will be start in around 5 minutes. So Svetoslav Solodushkin, are you here? I didn't see him in the list of presenters. So again, a very short coffee break, around 6 minutes, and we will start our next subsection. Okay, guys, we are approaching the next section, and I have a question for you. Do you hear me well? Because some conference participants said that it is a very bad connection from me.
Yes, Mikhail, we can hear you nice.
Okay. We have our next presenter here, Arsen Sagayan, and his presentation is energy consumption prediction of electric vehicle air conditioner system using artificial intelligence. Arsen, so you can start.
Sure. Hello, everybody. Can you tell me if you hear me, see me, and you see my screen sharing?
Everything is okay, Arsen.
Okay, great. Hello, everybody. Good morning. My name is Arsen Sagayan. I'm going to present you our paper, Energy Consumption Prediction of Electrical Vehicle Air Conditioning System using Artificial Intelligence. Let me thank you, first of all, the organization committee for the opportunity to present an organization of this event. Let's directly jump to the problem definition. So our problem is energy consumption prediction of air conditioning system, but our problem lies in the scope of another much bigger problem, a range prediction for electrical vehicles. Range prediction for electrical vehicles is much more important than such for internal combustion vehicles because of the high efficiency of such vehicles. And because of the high efficiency of electrical vehicles, they suffer from many perturbations on their range, on their systems from environment, from the driver, and from the car specifications itself. So that's why it's very important to measure factors which are affecting the range and trying to predict specifically range on the map. Exactly the way you see on the right, the probability for every place on the road which you can reach. So in order to do that, first we need to estimate the consumption of auxiliary systems in car. And one of the most energy hungry auxiliary system is the heating, ventilation, air conditioning system, which we are talking today about. Let me jump to the data. So as you all know, for machine learning algorithms, one of the most important stuff is the data, of course. And here you see a slide where we mention such data as map, weather, traffic, chargers, which are coming from environment. We have as well the data coming from the car, such as car model, battery model, and then we have the driver affecting, for example, the speed profile, acceleration profile, and the settings of heating, ventilation, air conditioning system. So in order to do accurate range prediction for the electrical vehicles, we have to take into account all these kinds of input information from a different nature and different sources, which are even sometimes hard to parameterize. This is why the machine learning is the key for solving such problems. And here you see on the left, the black, the data we're using here for the weather, car battery model, and heating, ventilation, air conditioning settings. We're using that to predict the energy consumption of AC. Let's see what kind of data we were using. So our data is coming from a virtual environment, which most of automakers use in order to test their cars before they run to series. So this model-based MATLAB simulation environment is used in order to, for example, check vehicles for the acceleration, energy consumption, and other dynamic parameters before they are even built. So further on, these technical specifications measured from the virtual simulations go to a technical sheet for the vehicle. So the dynamic specifications is not measured on the real prototype on the road, but rather than the simulation in that MATLAB. So that's why such simulations, they're very accurate, and their departments include hundreds of model-based engineers working in order to improve that. Our virtual simulations include in total 17 roads, 35 trips, 120 hours, and 10,000 kilometers driven. And they include the structural and speed limits components for all the important, let's say, main known roads of the Europe and some the USA roads. The cities, for example, which our virtual cars pass through, you can see in the slide. So let's see how do we analyze that data, what exactly data we're using, and what's the importance of that. In order to understand that, we've done air conditioning feature importance analysis. And here on the bottom, you see mentioned the signal names such as energy consumption, temperature inside, difference between temperature inside and setting. So energy sum window for last 5 minutes, let's say. Temperature outside and the difference between temperature inside and outside. Here on each column, you see the total feature importance for these features. And this data coming from the feature importance analysis, which we done based on the random forest algorithm. Random forest algorithm is very straightforward to analyze the importance of the feature because of its property to train random trees with a subset of the features. And here you see that we're not using only just features as is. We're also using, let's say, their time lag. Time lag is, for example, 5 minutes time lag is when we're, for the current moment of time, we're using not only the data coming from the sensor right now, but also the data which was coming from 5 minutes ago. And that's how we see that for temperature inside versus outside, or the temperature outside, the even 25 minutes lag is turned out to be a significant parameter to use. So worth to mention that besides all the parameters you see here, we're also using road inclination, which was turned out also to be important. So once we have realized the data we're going to use, let's see how do we process that. So in order to process data before using it for the classical machine learning algorithms, it's important to smooth such data. So let me show you how we're going to do that. We could use the average smoothing or some other likes window, which are, let's say, popular for such topics, but our smoothing comes from the nature. So let's say we're going from the point A to point B. We're not really interested in the energy consumption of any point in between of this trip, in this A-B interval, but rather than we're interested in the predicting how much energy the AC system will spend by the moment of time we reach the point B. So we're interested how much energy will be spent on the delta T. So as you see, this simplifies our problem that we should not predict the energy consumption line at each point, but instead we're going to predict the integral of that, which is a smooth function. And so by the natural understanding of the problem and setting the goals, the smoothing comes to our mind. And this kind of smoothing we're using. So instead of predicting the function itself, we predict its interval. And by the time we reach the point B, our prediction shows how much energy will be spent with this system. Okay, then we feed our information to, we mainly started with the most simplest classical machine learning algorithms to predict the energy consumption. The goal is to have lightweight, simple, and yet performance solution for this task. It's not, we could start with the building deep neural nets, but they never will run on a car. You will never be able to run them. But these two algorithms is very easy to implement with no libraries, let's say, used in C++, and then integrate them in car. As usual, we're using cross-validation. We have split our data set to training and test parts. And for the training part, we have further done 5 splits, where at each split we have 4 training pieces and 1 validation piece. On these 5 splits, we then fine-tune our hyperparameters, we ensure the best quality, and only then we do final evaluation using the test data. And our losses is mean average error, mean absolute error, and mean absolute percentage error. These two we use for just presenting. MSE was used for training, of course. So once we have our algorithms, once we have some results, now it's time to validate. And here I will show you the result of the validation versus the test set of the virtual simulation. So here you see two examples. So this plot on the x-axis has seconds, on the y-axis it has watts of energy spent by the system. And here you see about 100,000 seconds, but this is not just one trip. This plot is actually for the visualization purposes. It has several trips concatenated to each other, and here is the, like, let's say 5-7 trips at each plot. On the top, you see the result of the linear regression algorithm. On the bottom, you see the result of random forest algorithm. So we see that, okay, the random forest outperforms the linear regression in average for this all case, but also we see several problems which are occur for both algorithms. And which is interesting is that the problems are different. So our roads, our highway trips, they have different traffic scenarios. They have different weather conditions, and as soon as there is nothing change on the highway, you trip like is a smooth trip for a long time, the linear regression does well its job. But once there are several changes, on ramps, in ramps, traffic, or something else happening on the highway or in the city, we have the problems with the linear regression algorithm, and here random forest outperforms it by merging. So at the end, in order to include like benefits of both algorithms and try to neglect their errors, we use the ensemble with the 0.8 times the random forest and 0.2 times the linear regression. So simple weighted sum. And our resultant errors is about 7.76% for average case scenario. And we find this precision is quite enough for the first iteration of this algorithm and for including it to a bigger range prediction pipeline. So looking at the time, I guess it's about 10 minutes. Thank you very much for having me. Thank you very much for your attention, for listening, and let me welcome you to asking questions.
Thank you, Arsen. And I have a question about the instrument you used. Why you choose random forest? Because today there are we have much more powerful tools like XGBoost, like CatBoost from Yandex, etc. So,
yeah, so absolutely. Here, when we do this project, we actually, as this is kind of, let's say, corporate project, we here assume the complexity and the time needed versus the benefits we get after we implement. So I have given a try for the XGBoost as well as CatBoost for, let's say, trying to fit each algorithm for a few, let's say, hours each, finding hyperparameters the best to work. And what we've realized is that we are going to get like much more data, and we're doing right now the real trips, real driver trips with the real vehicle, and we will have to retrain and refit everything once again. And the time consumed by the boosting algorithms to get them tuned well is much more than you need time to train, let's say, random forest, for example. And the reason we've stopped on random forest and we didn't try more sufficient algorithms is also because it's much easier to implement it in car. So in car, we have access only, let's say, to the C++ code, which we can compile for the internal CPUs of the machine. And then we integrate it like that. And for the engineers to implement random forest inference or linear regression inference takes no time. So these are the main reasons. And answering your question in advance, I'll tell you that we're going to combine all these algorithms, all these energy consumptions of different systems on board together with the electric machine to make the range estimation. And there we are using already some more sufficient algorithms, more, let's say, difficult ones. But for the current problem, these ones turned out to be the simplest and the best performing ratio.
Okay. And can you please switch to the one of the previous slide where you have a map with point A and B?
Absolutely. This one, you mean?
Yes. And you noticed that the road has no effect on the performance. Which way we come from point A to point B? Yes.
No. Yeah. So you're asking if we have noticed no difference on the road we choose to come from
yes.
A to B.
Yes. Yes.
Yeah. Actually, Michael, there is a difference. So There are several interesting cases on which we suggest the most efficient road to take for the driver. It's just, it was out of the scope, the current work, and I didn't mention that, but thanks for asking. So here is how it works. Before the driver sets into navigation system the point B, all the calculations by the road path finding, let's say, an efficient road finding algorithms are already done. And the road from A to B, in this case, is the most efficient suggested from the navigation system. So it's, let's say, a pre-requirement for our algorithm to do so. And to, let's say, emphasize your question and show the example. For example, if two roads are possible, imagine two roads are possible. One is flattened road from the point A to point B, which you have no elevation change. And there is another road, which first you have a huge downhill, and then you have a huge uphill to take that road to reach point B. So even in this case, the algorithm at one scenario prefers one road and another scenario prefers the second. For example, if you have 100% of charge, it of course works to go with a flattened road. But if you have, let's say, not 100, but something significantly less, like 70% of charge right now, it works going downhill to use recuperative braking, recuperate the energy to the car back, to charge it, let's say, to 80 or 90%, and then take the uphill using inertia. And doing so, we actually reach the point B with the best state of charge, rather than going with a flat road. But this is the navigation system responsibilities, and it's performed right before the selecting road from A to B. Was this answering your question?
Yes, yes. Thank you again, Arseny. So we have no questions from the conference attendees, and thanks again. And we can move to our next presenter.
Yeah, thank you for the questions, Mikhail. Thank you for your attention and time. Thank you.
Thanks, Arseny. And we move to the next presenter, Mikhail Svetlakov. Gender, age, and number of participants effect on identification ability of EEG-based shallow classifiers.
Hello.
Mikhail, are you ready?
Yeah. 1 minute,
okay,
please.
So you may share your screen.
Okay, you can see it well?
Yes, everything is okay. You may start.
Hello. My presentation topic will be gender, age, and number of participants effects on identification ability of EEG-based shallow classifiers. So why EEG-based identification and identification? Many researchers showed a particular interest in biometric identification using various biometric factors such as iris scan, face or voice template, fingerprints, but EEG can have multiple advantages over them. EEG signals are unlikely to be forged or imitated. They're emotional state dependent, and it's guaranteed that user is alive and authenticating by his own. But there are some issues that in current researches that datasets used lack in representation, such as gender information or age information about participants. Also, more than 80% of works are on less than 50 subjects. Also, some researchers theorized that identification ability of EEG biometrics can be possibly decreased by increasing the number of participants. On this slide, you can see how number of participants are distributed over all works on EEG-based authentication. In this work, we used Lemon EEG dataset. It was collected at the Clinic for Cognitive Neurology of University Clinic Leipzig and Max Planck Institute for Human and Cognitive and Brain Sciences in Leipzig, Germany. This dataset have 227 participants, have multiple age groups. For each participant, 16 minutes EEG recording was taken. Each recording consists of 8 blocks of 60 seconds for a person with open eyes state and 8 blocks of 60 seconds with eyes closed state. Electrodes placement to USBEREIT standard, it's 1020 extended localization system. On this slide, you can see age distribution is used dataset and gender distribution. You can see that age groups are pretty imbalanced in this case. So for our research, we merged some of these groups into one middle-aged group. So we have one 20-25 age group, and second group is 25-16, and last group is 65-18. First group have 70 participants, second group have same number of participants, and last group have 62 participants. In order to data collectors already excluded 13 participants and a few channels. Downsampling signal, applied 8-order Butterworth filter, applied PC and IC, and back projected signal to sensor place. We made following adjustments, additional adjustments. Selected only which channels were to in each session. You can see channels names, selected channel names on this slide. And also we split the channels data to epochs with 2-second duration. Resultant dataset have 203 participants with 880 epochs per each of 17 channels. In order to extract features, it's important to tell about brain frequency bands. Usually in EEG signals, researchers distinguish multiple frequency bands. It's delta, theta, alpha, beta, and gamma frequency bands. Usually, in most of studies, only gamma frequency band is used in case of user authentication. On this slide, you can see a scheme of data pre-processing, additional adjustments. We take each channel's data and split it onto non-overlapping epochs or with duration of 2 seconds. When we apply a discrete wavelet transform, it have multiple advantages over other feature extraction methods used in EEG data cases. Wavelet functions also are localized in time, and it can give us important temporal information to use in our case. There are multiple wavelet types of wavelet functions. Usually only Haar or Dobish's wavelets are used. In our work, we used Dobish's wavelet of 4th order. In the case of discrete wavelet transform, signal is recursively splitted onto 2 parts, approximation and digitalization coefficients. We represent high and low frequencies respectively. Signal can be also reconstructed from taint coefficients using inverse discrete wavelet transform. So you can see we use high frequencies. We can extract gamma, beta, alpha, theta, and delta frequency bands from EEG signal. These coefficients form such array for each data epoch, and when we compute several statistical features for each channel coefficients, which we obtain using discrete wavelet transform, we calculate mean value, standard deviation, and root mean square. After feature extraction, our data dimensionality looks as we have 51 features and 297 samples. This method of feature extraction is usually state of art for shallow classifiers and can be in study which is written below on this slide. We used for classifier, we used linear support vector classifier, and it's actually ensemble of binary classifiers using one versus rest strategy. It means that we have ensemble of binary classifiers. Each binary classifier have positive data of one class and negative data of all other classes. We used Python package scikit-learn implementation of linear support vector classifier and used five-fold cross-validation scheme. It's slightly modified. We take mean value of 5 repeat estimations on each of the split. As a metric, we used accuracy, and you can see following results on this slide. This is age effect on classifier accuracy and gender effect on classifier accuracy. In case of age effect, there is a practical linear trend with increase of age, classifier accuracy also increases. In case of gender effect, it remains inconclusive because gender groups are pretty imbalanced, but age groups are more or less equal because we merged for our groups, which and it have 62 participants. Also, we studied number of participants' effects on accuracy. It can be seen that with increasing number of participants in dataset, accuracy also practical linear decreases about 10% per 50 participants. This was a case when we were using only gamma frequency band as features. If we use all frequency bands data, our data feature dimensionality also rises pretty high. Now we have 306 features, and classifier accuracy also increased pretty high. But when even with increased classifier accuracy, we can see same trend, but with value difference of lower magnitude. It's same case in with age effect on accuracy. With increasing age, accuracy classifier accuracy also increases. Gender effect on accuracy remains the same. And in case of number of participants effects on accuracy, it also can be seen that with increasing number of participants, classifier accuracy also decreases, but this time it's decreased about 1% per 50 participants. On this slide, its accuracy axis starts from 0.94. In previous slides, it started from 0. So that's all. If you have any question, you can ask me.
Thanks, Mikhail. I have a couple of questions. So it is not clear for me what is the features in your research. So in one of the slides, this slide, you mentioned about 51 features. What
50, we have In this case we use gamma frequency band. We have also 70 channels. We extract three statistical features from discrete wave transform coefficients, and it multiplied by 70 channels. So we have 51 features. Result.
Okay. And also, what states are you classifying? It's different frequencies or what?
We do not classify user states, or we classify which user EEG data belongs to. So we solve user authentication problem. We have EEG data of, in example, user one on input, and we classify to which user with data belongs to.
Mm-hmm. And you receive, in some cases, accuracy around 50%. Yes.
What?
And you receive accuracy around 50% in some experiments. Yes?
If we only use gamma band frequency band features, lowest is around 68 accuracy. If we use all frequency bands data, we have around 300 features, and the lowest is around 95%.
Okay. Okay.
It's actually it's 96% accuracy.
Mm-hmm. So okay, now it's clear for me. Any questions from the attendees? Okay. Thank you again, Mikhail. Very interesting presentation. And we have to move to our next presenter, Arseniy Glotov, with pulmonary fibrosis progression prognosis using machine learning.
Yep, exactly. Give me just one moment.
Okay.
Okay, I guess you can see my screen.
Yes, everything is okay. You may start.
Okay, so hello everyone. I'm presenting you the paper Pulmonary Fibrosis Progression Prognosis using Machine Learning. My name is Arseniy Glotov. I'm a master student from North Caucasus Federal University. So let's start. Our plan is to talk briefly about the pulmonary fibrosis itself, the data I had to work with, evaluation of the algorithm, because it's kind of complicated, the components of our solution, simulation process and its results, summarizing, and Q&A session in the end. So let's start with the lung fibrosis or pulmonary fibrosis. Imagine one day your breathing became consistently labored and shallow. Months later, you were finally diagnosed with pulmonary fibrosis, a disorder with no known cause and no known cure, created by scarring of the lungs. If that happened to you, you would want to know your prognosis. That's where troubling disease becomes frightening to the patient. Outcomes can range from the long-term stability to rapid deterioration, but doctors aren't easily able to tell where an individual may fall on that spectrum. So the problem is that we need to create an algorithm that could predict FVC, which is the forced vital capacity. It's the volume of air exhaled of the lungs of the patient with the pulmonary fibrosis. And in this paper, we present our solution, which is based on 4 algorithms. But first, let's talk about the data we had. So the data set is the tabular data and CT scans, but we will focus mainly on tabular data because that's what we used in our solution. So the data set contains column patient. It's a unique ID for each patient weeks. It's the relative number of weeks pre-post the baseline KT. It's actually maybe negative. So yeah, CT, I mean, the computer tomography of patients' lungs were taken only once among all measurements. So we have VVC, of course, which is, as I said earlier, forced vital capacity. We have column percent. It's a computed field which approximates the patient's VVC as a percent of the typical VVC for a person of similar characteristics such as height and weight and gender, etc. Age, which is patient's age, sex, patient gender, smoking status. It's actually a nice column. It can be like, we can have a patient who is or currently smokes, or he's an ex-smoker, or he never smoked at all. And the trained dataset contains 1549 measurements for 176 patients. So it's roughly from 9 to 10 measurements for every patient. And the most important part, test dataset is private, and no information about the size of it is available at all. Evaluation. So it's actually a competition on Kaggle platform. So the evaluation is complicated. It's a modified version of Laplace log likelihood, but in medical applications, it's useful to evaluate a model's confidence in its decisions. So accordingly, the metric is designed to reflect both the accuracy and certainty of each prediction. So for each true VVC measurement, the model will predict both an VVC and the confidence measure. It's actually a standard deviation sigma. And what you also can see in this formula is that the error is thresholded at 1000 milliliters to avoid large errors adversely penalizing results. Well, the confidence wells are clipped at 70 milliliters to reflect the approximate measurement uncertainty in VVC. So even with this parameter, we can't measure the VVC accurate, like 100% accurate. Now we move on to the first component of our solution. It's deep neural network with our architecture. So the input is pre-processed tabular information about the patient, and the result of the neural network is a vector consisting of 3 elements. And the file forecast is formatted as follows, as you can see on this slide. So it is important because, as I said earlier, we also need to predict the uncertainty of the prediction. And that is the way to do so. But the problem is how to train such neural network. Well, there is also a very complicated loss function. So it consists of 2 parts. The initial metric, which is modified version of log of Laplace negative log likelihood, and the pinball loss. The metric, this metric we suggest because it allows us actually to, first, it allows us to train such model to predict the uncertainty of the prediction. And also it gives us nice accuracy of the model in the end. The second component of our solution is gradient boosting decision tree. And we propose to use LightGBM implementation of this algorithm. It's a fairly common algorithm to use. And it's trained fast. Its inference is fast enough. But again, the problem is how to train such model for such task. So again, we propose another loss function for this algorithm, which is slightly modified Gaussian negative log likelihood loss function. As you can see, we sort of clip sigma as well, just to make training process more, just to stabilize it mostly. The second component is InGBoost, which is natural gradient boosting. It looks like a GBDT, but it uses natural gradients. It's a nice concept. You can read about it in the paper I just linked below. And this method allows us to use full probability distribution over the entire outcome space. And we can use the difference between the upper and the lower bounds of the 10% confidence interval of the predicted FVC value as the predicted sigma, which is also nice. So already we have 3 algorithms which can predict the FVC and the sigma. And we have 4th component of our solution, but it's elastic net. It's almost a linear regression with the combined L1 and L2 regularization. And this algorithm can produce the sigma, but it was used just to reduce variance in the final prediction of FVC. So what's the way to combine all those 4 methods? Well, for training and obtaining the final forecast, it is proposed to use the cross-validation algorithm on 5 folds with non-overlapped sets of patients. On each fold, predictions were obtained for the test as follows. By solving a system of linear algebraic equations using ordinary least squares method, the weights for the FVC predictions of each of the 4 algorithms were found. The fold prediction is obtained by summing the FVC predictions of the 4 algorithms multiplied by their weights. And after that, the values of sigma were averaged. We propose to average the FVC and sigma calculated by the above prediction method over all folds to obtain the final prediction on test set of data. As you can see it on screen, on the screenshot in right part of my screen. It's the basic scheme, how it actually works. So simulation and its results. In the end, we have that our proposed method gives us the lowest error on the test set of data. If we just take 1 by 1 algorithms from our solution and test it, or if you just simply average it, the predictions, the error will be much higher actually. So for summarizing, in this article, we propose an effective algorithm for predicting the pulmonary fibrosis progression. The algorithm is based on an ensemble of DNN, GBDT, and GBoost and ElasticNet. This approach makes it possible to use exclusively tabular patient data for forecasting without the need to access the results of his chest computed tomography. During the simulation, the proposed algorithm showed the best performance indicators in comparison with other considered methods. The code of the proposed method is available on Kaggle platform, and it's not licensed or something, so you can use that freely as you want. So that's all. Thank you for your attention. I'm open for your questions.
Okay, Arseny, thanks for your presentation. So I have a couple of questions. First, as I understand right, you built something like, ensemble of models, yes?
Yep, sure. But it just not like we are taking the mean of the predictions. It's like we are taking the mean with the weights, which are calculated by ordinary least squares method.
But I'm interested in slightly another detail. So you train each model in the separate fold, yes? Which is not intersect with other folds.
No, actually, it's the picture, I guess, that's confusing a little bit. We are training, okay, so in each step, we train all 4 models on the same data. Like we train all these 4 models on the same 4 folds. Then we get predictions for validation fault, which is left, and the test set. Now, we apply OLS algorithm to find the weights. Like we apply only OLS algorithm for trying to find the weights with which we can minimize the error of prediction on validation fault. So if we were just taking a mean of for algorithms, it would be 0.25, right? But with the OLS algorithm, we can find the custom weights. It's like it could be like 1.2 or minus 0.5 or etc. And later we can also use those weights to get the prediction on the test set.
Okay, and another one question. So if your work was based on the Kaggle competition, so the obvious question is, what is your place in the leaderboard?
Thank you for the nice question, actually. My place is 86th out of more than 2,000 competitors. So it's like top 5%.
Yes,
I got the
quite
silver medal.
Quite good.
Thank you very much.
Thank you again, Arseny. Very interesting presentation. But we move to the next presenter.
Thank you very much. Bye.
Bye. So Nikita Andriyanov, are you here? So you may share your screen and begin your presentation.
Hello, good afternoon, colleagues. Can you hear me? Can you see me?
Yes.
I can share my desktop. Yes. Can you see presentation?
Yes, yes, we see. Everything is okay.
And now, let's begin. The theme of my report analysis of the pattern recognition efficiency on non-optical images. The work was prepared jointly with colleagues from Ульяновsk State Technical University, and I am represent financial university under the government of the Russian Federation. About actuality of the task, in this paper we consider two types of images that not in optic range, but in some other frequency ranges. First type of images is radar images, or they are also known as synthetic aperture radar images. This type of information provides some benefits. For example, such type of registration of images, for example, Earth surface, can be obtained in different weather conditions, in different times of the day, at the night, evening, from clouding, from rains, and other. So radar images may be used when we can't get normal quality images in optic range, so we can use radar images. And the second type of images is aviation security. They means X-ray images when scanning luggage or hand baggage of passengers in airports and other places with many people. However, such images have some features that differs them from optical images. For example, on the slide, you can see on the left baggage on X-ray image. It is quite difficult for person to detect and correctly detect some objects on such images. And here we can use different angles of view to detect better. And on the right, you can see a surface radar image. The main features of radar images is, of course, bright places on such images, which says about good reflection properties. So maybe some objects with such surfaces. And of course, the convolutional neural networks uses for image processing and recognition tasks. And for radar images, brightness is very important, because if we will do convolution, it can affect very strong for the results. The first stage is about radar images processing. You can see examples of some images with different objects. So we test databases from Sandia, and our sample was consists of 3 types of objects: planes, roads, and ships. Unfortunately, the open data sets are very small, and on this slide you can see a number of images for every class, and we divide it in 3 samples: train, validation, and test. However, we can also say that this data set is unbalanced. For example, images of roads is 30 in train data set, and the images of plane and ships are only 9. We use augmentation procedures for initial original data set. Examples of such operations is presented on the slide. It allows us to get more representative data sets, and we try to solve the problem of unbalanced data. However, in the augmented sample, roads are more than other classes of images, but in relations, the difference is smaller than it was at initial data set. For these samples and initial samples, we try to implement convolutional neural networks with simple convolution and pooling layers and small filters, and the last layer was flattened. We use it to class the images on 3 types. Every image can be marked only as one class. We test different architectures of neural networks, deep neural networks. It's convolutions with 2 layers and 16 neurons, 3 layers convolutions, and 16 neurons on a flattened layer. We also use different optimization methods, but it's only 2 methods: stochastic gradient descent and adaptive moment optimization is we also compare different data sets. We can use train data from source, original data set, or train data from augmented data set, but the test data was always the same. And on this table, we can see accuracy results. It should be noted that the last line on the table, such architecture and settings of neural networks allows to get optimal accuracy on the all data sets, but it should be noted also that data set is quite small because initial data was very small. This slide shows examples of learning characteristics where we can conclude that after the 25 epochs, we get optimal accuracy, and we don't have our learning of the neural networks. However, we get unbalanced data set. We also use precision recall metrics. This slide shows the results for the one of the convolutional neural networks, but not optimal in the previous network. Here we can see that the road is more easy to recognize. So it has one precision metric and one in recall. For the plane and the ship, neural networks makes some mistakes, but these mistakes is only between these classes of images. This slide shows the example of processing different images. We can see probabilities for different classes, and these slides allows to conclude that it's obviously that roads is very easy to recognize against ships and roads, but there are some results where probabilities for road and ship are close to each other. For example, we can see at last line, the fourth image, it's about 57% for plane and 42% for ship. And the second part of the work is the processing of X-ray images. We have a data set from Ульяновский airport, Восточный, and we pre-processed images such way that one image consists only of one object, and we divide these objects only in two classes. These classes are allowed items and prohibited items. We also use standard convolutional neural networks architecture with convolution and pooling layers, and process by such networks with different parameters. Again, data set is presented on this slide. We can see that this data set is also unbalanced. Allowed or permitted images is main images in this data set because many images which we get in data sets, and it is a real data. It's often items that security allows to. using the airports, in the airplanes. We processed these data sets with different architectures again. We also use different number of training epochs, different optimization methods, and this table shows the accuracy results. We can see that the best result on the last line in the table, the more deeper neural network. We use full channels of brightness for images. This networks is also have learned 100 epochs, and the results is about 90%. This slide shows the example of learning process for one of neural networks, but it's not the best. We can see that accuracy is about 70%. It's one of the networks from previous tables, but we can also see that there is no effect of overlearning for this network. Due to unbalanced data, we also use precision and recall metrics for the best architecture and settings. We get such results. We can see that all metrics are quite good. They are close to 90% or for prohibited and for allowed items. And however, in this task, maybe it isn't not a good result, because we have to we must detect to recognize prohibited items very good. It's the priority of in this task, but about future research. We also compare X-ray images processing on by known architectures. So we use transfer learning, and we can see that our results is the worst, but our architecture is the simplest. However, the best results was shown by ResNet, and in accuracy metrics, this was about 97%. And this slide shows some results of prediction classes for images, also predictions with probabilities. And we can see that for some, most of images are classified with big confidence, but some images have 50-50 probabilities. For example, as the last line, the third image, it's 52% for allowed and 48% for prohibited item. But it's the glasses. Allow is the right answer. We also test regularizations methods, but compare only accuracy metrics. Their main results, so you can see on this table. It should be noted that deeper architectures provide better accuracy results on low levels, very quick improvements, and then improvements will be smaller. It's interesting that dropout regularizations, the best results for such type of regularization was obtained when we set dropout only 0.1, and augmentation on batch level with different probability also provides the improvement of neural networks. For example, we can see that augmentations with probability 0.2 for our data set provide the best results. And it also should be noted that neural network considered in this table is not the best, which provides 90%. It's one of the others. This research is more about dependencies of different regularizations methods. Conclusions are following. We develop architectures to processing radar images and investigate accuracy and precision recall metrics for such images. And the best results was provided with ADAM optimizations and 3-layer neural networks. We did this investigation for X-ray images too. Our best results was about 90%. It's also neural networks with deep layers and with ADAM optimizations. And we also investigate dependencies on regularizations. So the conclusion from this investigation is the necessary to use dropout and augmentation to provide the better accuracy. This work was supported RFBR, and we also would like to acknowledge symposium organizers. That's all, I think. Thank you for your attention. I'm ready to answer the questions.
Okay, Nikita, thank you for your presentation. I have a question about the train test split in one of your slides regarding to radar images. In this slide, there was 180 samples in all data sets and just 3 or 5, yes, this slide. So you have very big train and acceptable size of validation data set, but test set is, I think it is very small. It may corrupt the quality of your model. You don't think?
Yes, it's a problem that in original data here on this slide, there was very small images in data sets at all. Our idea was to compare algorithms on the same data. So just we have here such small samples, but images on these data sets in source originals from in-taste data are equal these images. It was done to compare on the same images. However, it is the problem.
Okay, I understand. Any other questions? So if there is no questions, we can go to the coffee break until 2:45 p.m. according to the Ekaterinburg time. So it is 20 minutes. Okay. See you in 20 minutes in 2:45. Okay, dear conference attendees, we are approaching to the block of another 4 interesting presentation. And the first presenter will be Marina Bardamova with presentation Hybrid Algorithm for Tuning Feature Weights in a Fuzzy Classifier. Marina.
Good afternoon.
Good afternoon. So you may share your screen and start your presentation.
Okay, thank you. My name is Marina Bardamova, and I am a researcher at Tomsk State University of Control Systems and Radioelectronics. The present part of my research is related to the development of algorithms to improve the ability of a fuzzy classifier to handle imbalanced data. The purpose of this work was to create and investigate the possibilities of an original algorithm for tuning feature weights to improve the quality of fuzzy classifiers. For this purpose, it was necessary to conduct an experiment of constructing fuzzy classifiers using the weighting tuning step and to compare the accuracy before and after the introduction. In addition, it was important to test how the weight tuning step and the term optimization step were combined and to compare the final results with those of foreign colleagues. My presentation consists of 3 parts. In the first, I talk about fuzzy classifiers and my idea of feature weighting. A fuzzy classifier is a machine learning algorithm that performs classification using the following kind of rows. Each row contains a list of used terms in the if part and the class label in the z part. Terms are membership functions that illustrate fuzzy sets. Unlike classical sets in which an object either belongs or does not belong to a set, in fuzzy sets an object can belong to it with some degree, ranging from 0 to 1. The rule base is created by the structure generation algorithm. Our laboratory prefers compact classifiers, so we use an algorithm that generates the smallest possible numbers of rules equal to a number of classes. However, it may not be sufficient to obtain high classification quality, so additional optimization steps are required to increase the accuracy. One common method of improve accuracy is feature selection. But my idea that some features may be more important in determining the output variable, while others may be less important. In other words, they may have different degree of importance. This can be expressed as a weighting coefficient, ranging from 0, which means that the feature is not important, to 1, which is the maximum importance. In the traditional approach, all of the membership function values corresponding to the row are multiplied to calculate the belonging degree of the input object to this row. In a weighted classifier, the values of the membership function are additionally multiplied by the weight. Finding the optimal feature vector is an optimization problem. Meta-heuristic algorithms can be used to solve it. I have previously worked with 2 meta-heuristics for feature selection and term optimization. The following I will describe them and the proposed hybrid algorithm. The gravitational search algorithm is based on the application of formula based on Newton's laws of gravity. The input agent population represents a system of particles. Particles with the best fitness function have a high weight and attract smaller particles. As they move through space, particles update elements of their vectors. At each iteration, quite a lot of calculation are done for all particles, including not only calculating the fitness function, but also finding distance between each particles. The Therefore, this heuristic works quite slowly. Shuffled frog leaping algorithm, on the other hand, is a quite fast algorithm. All engines are sorted and sequentially partitioned into groups. Within the group, for a given number of local iterations, the worst engines are moved to the best ones using the operator on the slide. After the completion of local iterations, the population is sorted again, and the whole process is repeated in. Although the algorithm is fast, it does not always produce large changes in the original population. To reduce the disadvantages, I decided to combine these heuristics. The gravitational algorithm is external. The local switch from the shuffled frog leaping algorithm works internally. This allows us to reduce the number of external iterations. The hybrid algorithm takes a population of vectors with weights as input. I generate the primary vector weights by estimating the mutual information between features and classes, then normalize it and apply random deviation to create other vectors in the population. The optimization algorithm works for a given number of iterations and output the best finding solution. I use geometric mean accuracy and the fitness function. The experiment consisted in constructed fuzzy classifiers on imbalanced datasets with two classes. The raw base was generated by an algorithm based on the extreme values of the classes. Then the weighting coefficients of the features were tuned, and finally the optimization of the terms was carried out. The slide shows the description of the datasets. A total of 36 datasets were used with varying degrees of imbalance, from very low to impressive. Here are the results. The geometric mean accuracy before optimization, after tuning of weights, and after optimization of terms. Since the presented numbers are not very informative by themselves, I will go straight to the comparisons. The first task was to compare the quality of the classification before and after the optimization. The geometric mean accuracy increased by 16% when the weights were tuned. After optimizing of terms, the accuracy increased by another 4%. The final improvement compared to the accuracy before the optimization was about 20%. When random switch was used instead of the proposed hybrid algorithm to tune the weights, the resulting accuracy was lower. This was the second stage of the comparison. In the third step, we compared our results with foreign colleagues. They verified the efficiency of constructing fuzzy classifiers on balanced data using the following approaches. Two classic structure generation algorithms, Chi and Ishibachi, with an algorithm for creating artificial instances of the smallest class to correct imbalance in the data. The third, the E algorithm, which is a special version of Ishibachi algorithm for imbalanced data. And the last is the algorithm for constructing hierarchical fuzzy classifiers, is also with the technique of data oversampling. Besides the fact that almost all of these algorithms use oversampling, they have 60 rows in row base versus 2 rows in our classifiers. The comparison showed that our classifiers demonstrated higher accuracy compared to the two methods, showed comparable results with the Chi algorithm, but were worse than the hierarchical classifiers. So the developed algorithm for feature weights tuning allows improving geometric mean accuracy of fuzzy classifiers. But it is necessary to use the feature weights tuning together with the optimization of term parameters. The developed algorithm showed satisfactory results when compared with analogs that have a larger number of rows and use data preprocessing. Thank you for your attention.
Okay, Marina, thank you. And I have a couple of questions. First, can you please describe what data set are you used for training? Yes, this slide, a lot of data set. What is it? Is a special set for your task or just data set from different papers? Or what?
Thank you. It is different data sets from open repository from Spanish researcher. It represents different tasks of classification in medicine, in economic, in industry, different types of data with two classes, only two classes.
Okay, and another question is about gravitational force algorithm which you are using. What type of forces between elements are you using? Because for instance, in molecular dynamics, it is very sensitive to choose different type of forces. It may lead to absolutely different effects in the evolution of system.
Thank you. Here, use only Newton's laws of gravity. The first, where we can calculate the forces between particles, use the mass and distance between them. And the second law, where we calculate the acceleration, use forces and mass of particles.
Okay, thanks. And Marina, it seems to me that I started the section 5 minutes earlier than it should be. So sorry for that. It's my bad.
It's normal. Okay.
Okay, Marina. So if there are no other questions, so we move to the next presentation by Kristina Morozova. Are you here? Yes, you're here. The presentation is Development and Research of Neural Network-Based Methods for Reconstructing Audio Signals. So, Marina, share your screen.
Hello.
Hello.
Do you see my slides?
Yes, everything is okay. You may start.
Okay. Hello, dear participants of conference. I present you our scientific work on the topic development and research of neural network-based method for the reconstruction audio signals. In general, audio signal processing consists of several directions: elimination of noise, audio loss restoration, reconstruction of the distortion signal, isolation of a part of audio signal, and other. We are working in the field of audio signal recovery. Reconstruction of audio signal is a fundamental problem that is usually solved using the signal processing and machine learning techniques. One of the significant words in the field of signal processing, we consider the tool Audio AI. This tool was based on the neural networks. A neural network was used to select specific part of an instrument. Initially, it was vocal part. The significance of this work is that the developers have shown that we can work with an audio signal as with image. decompose it into frames, and get the results using convolutional neural networks. Thanks to convolutional neural networks, you can consider several frequency pools and get restore one as a result. Let's consider our case. Some blues song was taken as a studied sound signal. As a particular task of restoring an audio signal, we are interested in restoring a lost drum part. The audio signal without a drum part is restored to a signal with drum part. On the slide, you can see frequency decomposition of the original audio signal and the audio signal with removed drum part. To get a set of evidence for future work, the audio signal should be decomposed. We use the Fourier transform. The entire signal undergoes Fourier transform, as a result of which the audio signal is characterized in space and time. Namely, as a result, we have an array of complex numbers which shows the phase and amplitude of the audio signal and specific frequency interval and specific time interval. Then the first half of the signal in time is transmitted to a neural network for training. Prediction occurs on the second half of the audio signal. We need to restore a drum part in each specific frame of the audio signal, or leave if the drum part is not needed there. Suppose that there is some kind of dependence between the current frame and the neighboring ones, which we can restore using convolutional neural networks. To restore one single frame, we consider 285 consensus frame. Let us assume that this number is enough to establish the all complex dependencies in time and between different frequency range. Therefore, out of 25 frames, we restore one frame in the middle. The original solution was to reconstruct the 512 frequency range in the input audio signal using single neural network. Initially, we used an architecture depicted on the slide, which restores the entire frequency range at the specific time interval. The initial implementation of the neural network was quite time-consuming, both in training and the work. Nevertheless, it was not possible to obtain high-quality results, since the output the network produced a noisy original outcome of the original signal. The constructed architectures of the neural network assumes to restore just a part of entire frequency range by splitting the range into several. Namely, each network processed its own frequency range. And it was supposed that such approach should improve the accuracy of reconstruction by reducing the number of unknowns to be reconstructed. The same 512 bands are processed by 32 neural networks, which are returned 16 frequency bands as output. It is important to know that to improve reconstructed audio signal, the input layer with dimension 512 25.2 transforms through the network to dimension 16.1.2, and then it's added to a corresponding input part of the audio signal which has the same dimension. Thus, it's not pure modification of the audio signal that is performed by the addition of the original signal with the restored missing elements. To improve the results, we increased the number of neural networks and therefore reduced the frequency range processed by each network. For example, using 64 networks and accordingly 8 frequency range of the 512 for each network. As a result, the obtained frequency complements of the original audio signal become more pronounced. The reconstructed audio signal is closer to the original due to the fact that the coefficients of the neural network become to a more specific set of unknowns. We show the spectrograms of the original audio signal with the drum part and the audio signal which was obtained using the neural network with 16, 32, and 64 networks, respectively. At these figures, you can ever visually notice the similarity of the original and the reconstructed signal, which is indicator of the method's quality. In this way, as can be seen in images with an increase of number of neural networks, the result is work is getting closer to expected. But at the same time, the noisy level of the audio signal also increases. Why are pictures used to evaluate the result? The metric used in training is loss function MSE. The loss function is used to indicate how far the forecast deviates from the target values. During the training phase, the weights are updated based on this amount. While the neural network is training, the losses are reduced, which helps to track the progress of training and the current performance of the network. The value of the matrix in our case is not informative for evaluating the prediction results, since it's not clear where the drums appeared in the audio signal or frame of noise was obtained. The result perceived enough by ear, so we can say that main indicator of evaluation is subjective. And within that framework of this work, the task was set to restore the signal, and it can be argued that if some components were removed from the signal or its distortion occurred, it is possible to build such a complex regression model using the missing data dependencies on the remain, which allow us to restore our signal. Thank you for your attention.
Thanks, Christina. And I have a question about, do you have any numerical metrics which proves that restored signal is almost like original one?
Thanks for question. I will try to answer as I understand it. You can evaluate the result of the forecast by clicking on the link in our paper.
Mm-hmm. Okay, and you present the architecture of a neural network. Could you please describe what type of convolution do you use? Does it affect the performance?
Sorry, I don't hear you quite clear.
What type of convolution do you use? What is a convolutional kernel?
I misunderstood your question. Could you please clarify it? There are some layers, convolutional pool, conv, if I understand you right.
Please repeat.
There are some layers in our network. Input, several inputs, convolution layers, pool layers, flat layers, dense, if I understand you right.
Yes, my question is about convolutional layers. What kind of kernel, convolution kernel do you use? Did you try different convolutional kernels? Does it affect the performance?
I'm sorry, I don't understand your question.
Okay, I can write my question in chat and you can answer by text, okay?
Okay.
Okay, so we can now move to the next presentation. This is Uliana Pavlova with presentation, development and research of the time series prediction method based on the finite state automation.
Is it okay?
Okay, we see a presentation. Uliana, you may start.
Thank you. Good evening, dear colleagues. My name is Pavlova Uliana. I present my work, development and research of the time series prediction methods based on finite state automaton. Let's define a time series at first. Mathematically, the time series can be described as a sequence of values with discrete time. When we try to predict the time series X, it's required to estimate its value in the future time t+1 on its available history. In our work, we consider some of the classes of sequence that we are trying to predict using an automaton. First, it's multilinear sequences. It concatenates string P and S for string Q. And the second, it's real-time series that are given by unknown probability distribution. The version of the algorithm our work is based uses 10 heads that move through the sequence and help in predicting further characters. This automaton is able to master any multilinear words. The scheme shows the 4 main heads of the automaton. To completely master the string automaton will alternate between 2 procedures. It's procedure correction and matching. The correction tries to locate each of read heads H1, H2, H3, and H4 at the beginning of the segment following one after another. Next, matching procedure tries to master the string, assuming that the correction was successful. Matching works by using H1, H2, and H3 to predict H4. It moves all read heads together and uses the previous heads to predict H4. Once all heads are at the beginning of the segment, matching repeats from the start. If some problem was found, for example, guess is incorrect, the matching procedure stops and the correction starts again. For more detailed study of the structure and scheme of the automaton, we tested it on different sequences. If the automaton detects a deviation from the multilinear sequence pattern, it starts from the beginning of the correction function. As a result, we got a significant decrease in the quality of the forecast. We decided to make some changes to its structure to make it more suitable to work with real-time series. The first main difference from the original model is the processing of the automaton using the principles of machine learning. The entire sequences is conditionally divided into training and test parts. This means that before starting to work, the automaton learns on certain number of symbols of the sequence. The next change directly affected the prediction function. In the original model of the automaton, the prediction was made only during the matching procedure. Based on the assumption that the prediction should be carried out at each movement of the rightmost head of the machine, the prediction method was also added to correction procedure. Next, a restriction was added to automaton, which allowed the function to continue working only if the current head had already clearly passed the training stage, but did not reach the end of the test sample. Further, a tracking method was added designed to fix the function from which the forecast called. Thanks to this, it became possible to get the number of prediction and the errors in them for each individual function. The result of this you can see on the screen. At each step of the automaton operation, a sequence of symbols predicted earlier was supplied as an argument to achieving function. Inside the function, all characters from the existing alphabet are alternately written to the end of the sequence, achieved and deleted. After achieving, the function returns the file size, which is compared to some minimum. Thus, the smaller file size and the symbol with which this file size was received are selected. All used modifications and improvements were tested on the real-time series and showed interesting results, which allow us to continue the research of the automaton predicted methods. That's all. Thank you for attention.
Okay, thanks, Uliana. It's a bit not clear for me. What kind of time series did you use? It's randomly generated, or it was provided by some real-life source?
First type, we used the multilinear types of sequence. It's like this. And the second, it's real-time series, but we got a dollar exchange rate for a certain period of time.
Okay. And did you compare your results with well-known stuff like Facebook Profit?
No, did not compare it.
It's good for your future research to compare your
thank you.
results with others. Other questions? Okay, and thanks Uliana, and we move to the our latest presentation in this blog from Natalia Sevastyanova. The presentation is Algorithm for Recognition of Undefined Multispectral Remote Sensing Data.
You can see presentation.
Yes, everything's okay. You may start.
Good afternoon. My name is Natalia Sevastyanova. I would like to introduce my work on the topic Algorithm for Recognition of Identified Multispectral Data of Remote Sensing of the Earth. Earth remote sensing data has been increasingly used in many areas of human activity in recent years. Many of the tasks solved using remote sensing of the Earth operate in terms of the dynamics of certain changes in the terrain. And this requires the collection and processing of the sufficiently large amount of heterogeneous information over a certain period of time. Unfortunately, in some cases, when forming an image during its transportation or storage, it is possible to lose part of the information. An example of a damaged snapshot is shown on the slide. A multi-channel images contains not only an image of the area, but also other important information. Damage to this information causes critical consequences. It becomes impossible to read the image due to the lack of information about the methods of storing data in the file. Therefore, very often such data is considered lost. There are three main ways to store information in uncompressed multi-zone images: BIL, BIP, and BSQ. In the BSQ format, data about the channel is written to the file sequentially. The BIL format supports line-by-line recording of all channels. Data is entered in the file sequentially line by line. In the BIP format, all information is entered in the final file pixel by pixel. The correct identification of the data representation format is the key to the successful opening of the multi-zone image. The proposed methods for determining the data storage format is based on the Fourier analysis of the image. Fourier analysis allows you to identify patterns of alternation of the image content. The Fourier spectrum has a sensitivity to the periodic components of the signal, which is expressed in the appearance of peak values on the frequency axis. During the development of the algorithm, it is necessary to establish general patterns. To identify patterns, we will analyze the reflexing properties of surface in different frequency ranges, using the example of the data from the SPOT spacecraft. All these ranges correspond to the transparency windows of the atmosphere. Different objects in the images have different dependence of the spectral brightness coefficient of the wavelength. Fragments of images with different subjects were analyzed. The slide shows the spectral reflexivity of nature objects as well as the values of the average brightness of fragments for different spot channels. From the above data, it can be seen that for most fragments, the average brightness of images in different channels differs, but the patterns of brightness channels from pixel to pixel are preserved due to the correlation of channels. Fragments containing a snapshot of the Earth surface under a dense layer of clouds drops out of the list. The reason of this is the reflection of solar energy from the cloud cover. To identify the spectral features of the spectrum behavior, we use a typical real image. Let's take field fragments for a typical image. The image is decomposed into a vector stream in 3 different waves corresponding to 3 different formats for storing multi-zone data. The graphs on the OY axis show the normalized value of the spectrum, and on the OX axis the frequency. If the storage format is BIP, when the Fourier images analyzer shows peaks that divided the spectrum into segments, the number of segments corresponds to the number of channels. If the storage format is Basque, when a cardinal sin is observed in the analysis in the low frequency region. Moreover, it can be noted that if there are car channels, then each car's peak will turn to 0. Based on the above, an algorithm has been developed to determine the methods of storing multi-zone data stored in uncompressed files. The inference about the known format is determined by shape of the Fourier image spectrum. The scheme of the developed algorithm for determining the format based on the Fourier image is presented on the slide. The proposed algorithm has proven itself well in the processing of homogeneous images fragments. The slide shows the spectra of 2 fragments, despite in the fact that the infrastructure has lower and wider peaks. However, they are also traceable. The infrastructure is a non-uniform surface, so each channel has a large brightness spread, which in turn distorts of spectrum. In future work, it is planned to develop methods that restores damaged images. Thank you for your attention. I'm ready to answer your questions.
Thank you, Natalia. So my question is about practical application. Did you try only, model source of data or practical source of data?
Thank you for your questions. I'm sorry, my English is not very well. Can you please me write your questions using the chat?
Okay. If we have no other question, so we are going to the enlarged coffee break, even a lunch break, and our next section starts in approximately an hour. So the beginning of section is 4:15 according to the Yekaterinburg time. Okay, so see you in 1 hour. Okay, dear conference attendees, we are approaching to the next block of 4 interesting presentations. And the first one will be Natalia Popolovskaya with her presentation, while Heisenberg transferred capabilities in JPEG compression standard. Natalia, are you ready?
So I think that Natalia Poplovskaya unfortunately is absent. I will present the article. Okay?
Okay, no problem. You can share your screen.
Good day.
Natalia, do you agree?
Yes. Valery.
Okay. Yes. Okay. Do you see my presentation?
Yes, everything is okay. You may start.
Okay. So, good afternoon, dear colleagues. My name is Valery Asir. I'm a graduate student of National University of Science and Technology, MISIS. I want to present to you our new article, Whale-Hazard Transform Capabilities in JPEG Compression Standard. So this paper is devoted to the development and research of a new compression technology based on Whale-Hazard basis for modifying the JPEG compression standard and improving its characteristics. So currently, the most important role in digital signal processing is played by discrete orthogonal transforms, which are actively used in various problems of digital filtering and spectral analysis. Meanwhile, the math tools of discrete orthogonal transforms find their application in the field of data compression for the subsequent economy storage or transmission of data. An example is the discrete cosine transform, which has gained wide popularity and served as the basis for the development of data compression algorithms like JPEG, MP4, and MP3. So let's take a closer look at the JPEG codec. So we have, according to the JPEG standard, the image compression algorithm is as follows. The input of the codec is an image in terms of the red, green, and blue channels. Then the input image is converted to YCBCR color space, and color subsampling is applied to the color space components. Then the image components are divided into 8 by 8 blocks, to which discrete cosine transform is applied. The obtained spectral coefficients are quantized, as a result of which insignificant high-frequency elements of the spectrum are eliminated. At the final step of compression algorithm, run length encoding and half encoding are applied to the remaining spectrum elements. In this article, we propose to use the real discrete Whale-Hazard transform instead of discrete cosine transform. So, as you know, any discrete orthogonal transform is linear and has a matrix representation. Moreover, the most important property that the transformation matrix should have is the property of unitarity, which is written as equation 1. In this equation, matrix U is the square transformation matrix with discrete orthogonal basis functions along the columns. The main features of discrete orthogonal transforms are their reversibility, computational stability, and simplicity of implementation. The transform signal, which has changed its shape and appearance, can be easily returned to its original state. As noted earlier, JPEG standard is based on discrete cosine transform, which matrix is determined according to the following formula presented on the slide. In the JPEG standard, discrete cosine transform is applied to each block separately using the block discrete orthogonal transform. So the formulas of the two-dimensional forward and backward block discrete orthogonal transforms of the image matrix are written as presented equations. So in this case, we have block matrix of the image elements, block matrix of the image spectrum, and block image of the restored image elements. So let's take a look at the Weil-Hessenbeck basis. The complex matrix of the orthogonal Weil-Hessenbeck basis has the property of unitarity, and it's described by the formula 2. This basis initially has a block structure and is defined by the following parameters: time frequency shifts and phase. In image compression problems, we are dealing with a real two-dimensional signal, which means that the use of the complex WH matrix is not advisable. But by analogy with the Hartley transform, we can construct a real version of the WH matrix, which is determined by the formula 3 and its equivalent form, formula 4. In early works, we showed that the transformation matrix 4 is an orthogonal and satisfies property 1, property of unitarity. So in order to compare the developed discrete Weil-Hessenbeck transform with the block discrete cosine transform, in the image compression problem, we take the value of the number of frequency shifts equals 8, which actually corresponds to the 8x8 block separation. Then the value of the phase parameter alpha, in this case, equals 4. We also write down the formula for calculating the optimal value, where beta is a parameter providing optimal localization of the Gaussian function. After applying the block discrete cosine transform for the JPEG specification or our method, our discrete Weil-Hessenbeck transform in real space, the quantization operation is applied to each received block separately, which is described by the expression presented on the slide. So in this case, the quantization factor R in the formula 5 controls the compression ratio. The higher the value, the stronger the compression. This slide shows two quantization matrices. Matrix on the left corresponds to the JPEG standard, and matrix on the right to the proposed method. The values of the elements of the quantization Q for the discrete Weil-Hessenbeck transform, right side, were selected based on the features of the resulting spectrum. So to assess the difference between the original and the reconstructed images by discrete orthogonal transforms, we calculate the Frobenius norm of the difference between the original and reconstructed images. This formula will serve as a criterion for quality losses. Also, we use peak signal to noise ratio is often used to measure the level of the distortion in image compression. Since most signals have a wide dynamic range, peak signal to noise ratio is usually measured on a logarithmic scale in decibels. So we also introduce a value such as compression ratio, which defines the percentage of 0 elements in relation to all elements of the image spectrum. So to compare discrete cosine transform according to the JPEG specification and our methods according to discrete Weil-Hessenbeck transform at beta equals 2, in the problem of image compression, modeling was carried out for different values of the quantization coefficient. R equals 1, 4, and 8. Figures 2 and 3 shows as an example the results of compression the same image Berber.png at quantization coefficient 1, 4, and 8 using discrete cosine transform and discrete Weil-Hessenbeck transform. So in tables 1 and 2, corresponding numerical results are presented. In the case of the Weil-Hessenbeck transform, we have the lowest quality losses of the compressed image. This can be seen from the comparative analysis of visual and numerical characteristics. According to the simulation results, the discrete Weil-Hessenbeck transform provides an average of 20–25% preservation of image quality compared to JPEG at higher compression ratio. in conclusion, I want to say that based on the simulation results, can be concluded that the presented new approach to compression of raster images provides a higher compression ratio and greater preservation of quality during restoration in comparison with JPEG compression standard. Consequently, the use of the discrete Wilhelmsburg transform turns out to be a very effective tool in the problem of compressing and storing raster images. This phenomenon is explained by the fact that a discrete image is essentially a non-stationary two-dimensional random process. The features of this process can be fully studied only in the time frequency domain, having previously broken it into fragments. In this fact, is critical for filtering out non-essential spectral components and as a result, effective image compression. So that's all for me. If you have any questions, please don't hesitate to contact me in chat. Thank you very much for your attention.
Thank you, Valery, for a very interesting presentation. So my question is about the picture in your result section. So you applied your technique to the grayscale image. Does it make sense, or you can apply your technique both for grayscale and colored image?
Yes, of course. For the color images, we use color transformation as presented above to YCBCR color space. And later we apply color subsampling. In this case, we can compress image about we can compress all image, but technique presented for grayscale image and color image is equals are equals.
Okay.
But algorithm applies to all color components, luminance, CB, and CR. And the results will equals.
Oh, okay. And does your method has any drawbacks? Because the result looks. Does your approach has any drawbacks? Because your result looks very good. That it much better preserves quality than the standard JPEG. So why the standard JPEG does not use your approach here?
Sorry, I don't hear.
Okay.
You're telling about JPEG 2000. Or what?
Maybe I don't know.
Okay, Smith. Okay. Listen, according to the great characteristics, the JPEG 2000 compression standard ensures the preservation of image quality up 20%, like our proposed. But we have already managed to improve our compression algorithm, as a result of which the quality preservation was ensured up to 30%. But we don't publicate it yet.
Okay. So is it possible that your approach will be included in the next JPEG standard?
Maybe, I don't know. We want to create algorithm, create codec .haze and test it out.
Okay. So I wish you good luck.
Thank you.
In this deal, and we are going to the next presentation. Few seconds. Mikhail Gashnikov.
Hello.
So you may start. You may share your screen.
Do you see my presentation?
Yes, everything is okay. You may start.
My name is Mikhail Gashnikov. The topic of my research is hierarchical representation of plane arrays of post-interpolation residuals for image compression. Excuse me for my bad English. The structure of our presentation is as follows. First, we consider a hierarchical image representation. Then we describe general structure of hierarchical image compression method. Then we consider averaging interpolators for this compression method. Then we describe proposed modification of hierarchical compression method. And finally, we present the results of computational experiments. The considered image compression method is based on hierarchical grid interpolation. This method uses a special representation of the image as a set of disjoint scale levels. The most resampled scale level is simply a grid of image samples with a step of 2 to the power of the level number. Any of the other scale levels is a similar grid from which samples of a doubly resampled grid are excluded. This representation is convenient for compression since it is not only hierarchical but also redundant. Scale levels do not intersect, so we can compress the scale levels one by one from the most resampled scale level to the least resampled. When compression, we interpolate the samples of each scale level based on the samples of the less resampled scale levels. Compression algorithm for one image scale level consists of the following steps. Step number one, interpolation. We use already processed samples of more resampled scale levels to calculate an interpolated value. Step number two, calculation of post-interpolation residuals. We subtract the interpolated image samples from the original ones. That is, we can calculate the interpolation errors. Step number three, quantization. We use a uniform scale to quantize the post-interpolation residuals. So we control the maximum error between source and decompressed images. Step number four, coding. We use an entropy coder for reduce the data size of quantized post-interpolation residuals. And finally, step 5, recovery. We calculate the recovered sample values, which are the same as the values that we will later calculate during decompression. We use these reconstructed sample values to interpolate samples of the more resampled scale levels on the step 1. The described procedure provides the following advantages of hierarchical compression method. We can quickly decompress any image fragment at an arbitrary scale. We can provide high compression ratio and high speed of compression and decompression. We can efficiently eliminate archive damage and communication channel noise. We can stabilize the speed of compressed data stream and so on. We usually use simple averaging over the nearest reference samples for interpolation within the hierarchical compression method. Here you can see various two-dimensional and three-dimensional interpolation functions. Using these simple interpolators allows us to provide low computational complexity. However, the error of these interpolators increases on the contours. These interpolators work accurately on relatively flat areas of images. This leads to the appearance of plane areas in the array of post-interpolation residuals. Moreover, the size of these areas in the quantized array is even larger. This paper proposes to use a hierarchical algorithm for the efficient coding of these plane areas. So we coding the areas of quantized post-interpolation residuals. We coding the plane areas of quantized post-interpolation errors. We propose following modification of considered hierarchical compression method. We use some additional steps to process quantized post-interpolation residuals prior to entropy encoding. First, we reorder the quantized post-interpolation residuals so that the quantized values located at the same scale level are closer to each other. We then represent the quantized post-interpolation residuals as a tree. This representation allows us to find the zero subtrees and remove them from the encoded quantized array. Let us consider the proposed algorithm of hierarchical representation of plane areas of post-interpolation residuals in more details. As noted above, entropy encoding algorithms are usually used at the stage of encoding quantized post-interpolation residuals in hierarchical image compression methods. These algorithms can effectively eliminate the statistical redundancy of these residuals. However, these algorithms ignore the two-dimensional nature of these residuals. In other words, the relationships between the encoded samples for one of the dimension is lost when using entropy encoding algorithms. However, preliminary analysis shows that it makes sense to consider these relationships for hierarchical compression method. This paper proposes to use a hierarchical algorithm for the efficient coding of the plane areas of quantized post-interpolation residuals. First, we accumulate the values of quantized post-interpolation residuals for all scale levels of the image in a single intermediate two-dimensional array. Then we reorder this intermediate array to group the values of post-interpolation residuals located at the same scale levels. As a result, the plane areas of the array of quantized post-interpolation residuals increases in size. We represent the reordered intermediate array in the tree-like hierarchical structure. In this case, the levels of the resulting hierarchical structure correspond to the scale levels of the original image representation. The presence of zero sample in this tree-like structure with a high probability entails the appearance of zero samples at the next levels of the hierarchy. In other words, the described tree of quantized post-interpolation residuals with a high probability contains zero subtrees. We discard these trivial subtrees in subsequent entropy encoding, which leads to a reduction in the compressed data size. There are the experimental results. We used the free Waterloo grayscale image dataset for computational experiments. The quality measure was the relative gain delta in the archive size, which was achieved by using the proposed algorithm within the hierarchical compression method. You can see that the use of the proposed algorithm provides the noticeable gain up to 10% in efficiency. So we have proposed an algorithm for encoding quantized post-interpolation residuals. This algorithm is based on a hierarchical representation of the plane area of the array of these residuals. We have considered a hierarchical way of reordering quantities that post-interpolation residuals in order to increase the efficiency of coding of these residuals. We have experimentally confirmed that the use of the proposed algorithm for encoding plane areas of the quantities post-interpolation residuals array can significantly increase the efficiency of the hierarchical method of image compression. Thank you for attention. I will try to answer your questions.
Thank you, Mikhail. So my question is about practical application of your research. Did you try anything in practical?
Yes, the main advantage of this compression method is hierarchical. This method is hierarchical. So we have multi-resolution, we have fast access to the data. We can decompress any fragment in any resolution, and the time of the decompression is constant. So we can use this method in the big data set of images in the image repository, in the repository of space photo, in the repository of remote data. And also we have algorithms for stabilizing data compression speed and denoising. So we can use this method on the satellite if you have buffer memory for stabilize compression speed.
Okay. And I also have another one question. Do you have some information about state-of-the-art research in your field? Because in my opinion, remote sensing data is a quite hot topic.
We don't compare to specialized compression method for remote sensing data. It will be future research.
Okay. Thanks. Maybe any other conference attended have questions? Okay. If there is no other questions, thank you, Mikhail. And we are moving to the next presentation of Vyacheslav Filimonov, which called identification of patterns of development of the incidence of COVID-19 in OECD countries using cluster analysis. So Vyacheslav, are you ready?
Can you see the first slide of my presentation?
Yes, you may start.
Okay. Now, we are, of course, tired. The day was very long, but my presentation is very simple and very short. And I remember an explanation, the best explanation for it. It's a group of Piet Hein, Dutch scientists. I read it in English and then translate into Russian. It is important. Solutions to problems are easy to find. A problem is the main contribution. What is really an art is to link from your mind a problem to fit a solution. Решением проблем небольшая цена. Проблема дороже намного. К решению найдется, конечно, она, но мне неизвестна дорога. Так вот, проблема описана в статье большой, а я буду говорить про метод, про solution, которому мы искали эту самую проблему. The first is related parameters and clustering. In our paper, there is the task where some sort of connected process. It is very difficult to understand how these processes may be classified. And I say there are many problem statements and solution methods. There is a picture of one book, I think it's one of the best books, the Novosibirsk author Zagoruйko. I recommend it to you when you have to classify data. Data problems. The main problem is that the data sometimes are very dark and sometimes they are distorted. And in the book of How Not to Be Wrong of Ellenberg, there is a very interesting example how the dead fish, dead salmon, was the source of electric signals, and it was interpreted as empathy of dead salmon. This is a fake research, but it is very logical, this research. One of the most important, this is interpretation of results. I read two main questions. What does the customer expect to do with the response? And sometimes the customer don't meet at all this response. And this is a waste of your time to try to find an answer. And if you find an answer, does the customer understand the meaning of this answer, the meaning of this result? And it is very hard to answer to this question number 2. Sorry, but here I cannot in program of our conference any example of cognitive graphics. Here the Chernov faces, and I strongly recommend the books of Edward Tufte, the guru of cognitive graphics in the United States. The books are very interesting and very useful, and it is makes better understanding of your result. Instead of simple graphics, it's not when you make complex with ordinary graphics and cognitive graphics, this makes the best result of understanding your research. Special thanks program committee, I repeat it, for report computation humor, but there were not computation humor at all. There were some data processing of data that made some sort of equations to humor, but there were nothing laughing at in this report. But in every case, special thanks. Thank you for your attention. The results, this is the problem distinguishing between system characterized by parameters related to several processes has been posed and solved. And we find the direction of detailing the system and parameter understood at the moment. And it is very important effect of certainty in the data. So I think this is enough. The full text of paper is on site, and you may see numbers and graphics in it. And now I try to explain our approach to all this. Thank you for your attention.
Thank you, Vyacheslav, for quite unusual presentation, but still very interesting. And my question is about one of your slides about customer. So, who is the customer of your research? What does he expect from you, and does he or she understand what you receive?
Yeah, the customers of our research, there are two our co-authors from Omsk State Medical University. But I really know why, how they try to use these results, except of have some publicated in respective journal. I answer your questions, or you?
Yes, you answer.
This was honest answer. This was honest answer.
Yeah. Vyacheslav, and could you please, in few words, describe the result of your research? So you somehow cluster some patients with COVID-19, or what?
I repeat the last. Yes. I have read it in English. Я могу прочитать это по-русски. Значит, мы научились ставить задачу, различая системы и классифицировать. В каждой из систем идет несколько параметров, и они относятся к разным процессам. Например, это может быть не только, значит, пандемия, но это может быть образование и экономика. Вот. И мы определились, куда нам двигаться дальше, чтобы быть в состоянии учесть периодичность и вот эту вот неопределенность данных.
Okay. Okay, I understand. Any other questions from the conference attendees? Okay, Vyacheslav, thank you for your presentation again, and we move to the next presentation, which will be made by Andrei Sazykin. So the presentation is developing educational programs using a Russian IT job market analysis. Andrei?
Hello, everyone. Oh, sorry, I just opened my presentation. Could you see it?
Yes, everything is okay. You may start.
Okay, so our work is a part of a big project, Human Resources for Digital Economy, and inside this project, we try to develop a new approach to creating educational programs. Often, educational programs are created using a traditional approach when we teach what we really know, instead of teaching some in-demand skills. And when we want to try to teach skills that are really required by companies, but what skills are in demand, first of all, we should know which skills to teach. And we create several tools to collect data from open source, from first of all, job advertising sites. We create a data set and we analyzed some data and proposed approach to how can we use collected data to develop educational programs. First tool that we built is so-called vacancy analyzer. You can download it from GitHub. Excuse me for Russian, but it's nowadays it's only for Russian language. So these tools is aimed at collecting data from job advertising sites. Nowadays it supports collecting data from Headhunter with job advertisement and with Hubber for creating and teaching language model, which we use in our steps to analyze data from Headhunter. Demonstration version, which are available on this site, could be used to download data from Headhunter to actually we have two options. You can use Postgre and you can use Hadoop for really large-scale analysis. We spent 3 months to collect data from Headhunter, and we create a data set of job advertisement. We have roughly 3 and 7 millions of job advertisements. They are only in Russian, and all of them are related to IT jobs. We also provide open access to dataset through IEEE data port. Here you can see the link, and it's also in the paper. If you want to do analysis of job advertisement, you can do it yourself by downloading this this dataset from the link. And we also on this link you can download not only our tools for downloading data, but also Jupyter notebooks, which allow you to recreate the analysis and graphs that I will show you. We do some pre-processing and clustering and NLP processing of job advertisement and create so-called IT skills ontology. The main problem that we tried to solve is that various companies use different words and topics to talk about the same. For example, we can use mobile development, iOS development, Android development, but all of these topics are related. And when we see, for example, in job advertisements that we need an Android developer, that we should understand that this topic is related to mobile development and so on. And some results of those pre-processing are also presented in our data sets. The skill in these data sets are actually we have raw text from job advertisements, and in addition we have name of the skills from the ontology which are already pre-processed. After collecting data, we do some analysis. Actually, we have 3 types of analysis. First type of analysis is we try to study the trends in various topics. First analysis is the analysis of trends for in-demand in IT profession. It's not surprise that most in-demand profession is developer, but other positions such as tester, team lead, product manager, and nowadays even data scientist are also popular. And we started our analysis with developer, but also present two programs about analyst and software tester. For each topic, we presented top skills which contained in most of job advertisements. Now here you can see top 15 skills for software development, and number 1 skill is SQL, number 2 is Git, and so on. Here you can see top 15 skills for project managers. We have our dataset in Russian, and for software developer skills, almost all of them are in English, except for 1S software development, 1С программирование, because 1S is a Russian product. But for project management, most of skills which are required are soft skills, and they are in Russian. So as the most in-demand profession is developer, we concentrate our efforts on study the demand for programming languages. Here you can see how demand from Russian companies changed over times. Nowadays, the most popular programming language is JavaScript, although it's declining in popularity. 1st and 3rd languages are Java and Python. For both languages, popularity is growing and demand for them is rising. The 3rd step that we do is that we analyzed not only languages, but also so-called co-occurrence of technology in job advertisement. Often languages are required not by themselves, but to do some specific tasks. For example, JavaScript most of the time required for web development. And in order to be successfully employed, the developer must not only know JavaScript, but also know web development skills and at least have some experience. For Python, the most important topics are data science, and most of job advertisements that require Python also require knowledge of machine learning, data analysis, and other libraries. Unfortunately, we didn't do this analysis for Java, but as what we can see from rough description, that Java is required for enterprise development, such as big banks and so on. So we decided that if we want to develop educational program that help our students to find a good job, we need to teach them not only programming language, but also related technologies and related frameworks. First of our educational program is related to web development in JavaScript. We studied the trends for demand for web development skills. It's obvious that HTML and CSS are most important skills, but they declining in popularity. And what is related to React, we decided that for web framework, we decided that we should teach React, because it's nowadays not the most popular web framework, but its popularity increasing. In contrast to, for example, Angular, which is most popular now, but it's declining in popularity. So this is our proposal for educational program for web developer. We develop its program as a vocational program. It's additional education program as we use in Russian, but these courses also could be used as a part of bachelor or even master programs, for example, as an individual track. First course is Foundation of JavaScript. Second is HTML and CSS, which is required, and React as a as we think most promising web development framework. The next program that we try to design is data science skills. We also studied the trends for required data science technologies and libraries. First of all, that we can see that demand for data science skills started at 2015, and so it's as an industry skill, it's roughly 5 or 6 years old, and we include the most popular technologies in our program. Of course, we started with Python. Also, we included a course on SQL because SQL is often used to prepare data for analysis, because we need to extract data from either classical databases or big data databases, most of which nowadays support SQL. Of course, we need to study data analysis and classical machine learning. And in addition, we need to know how to use deep learning. So the next program that we try to develop is a software tester. Here you can see a cluster skill for which required for software testers. SQL is the most in-demand skill for software tester as well as for developers. We studied the software trends, and for testers, required technologies is, of course, testing and QA. From technologies, Selenium, JUnit, and Postman are used most often. So we decided to include that topics in our program. First topic is foundation of SQL. Second is quality assurance and testing. Next course is user interface testing, primarily using Selenium. And the last course about unit testing, functional testing, and API testing using Postman. The last program that we designed related to IT analyst. Actually, for analyst, we have not one, but two cluster. First cluster, you can see it in a red circle, most related to business analysis. For example, market research, business intelligence, Excel, and so on. And another cluster is for technical IT analysts who develop a technical specification using UML, some languages of business process descriptions, and so on. And here you can see proposed of our educational program. SQL is often required by companies for analysts. Of course, they need to know how to do analysis and business analysis. We have a course for business process management and for technical specification development using UML and other required tools and in Russian it's of course GOST. So we try to develop a new approach to create an educational program based on the requirements of companies. How we will know what is required by companies? So we try to download data from internet. We created a tool which allowed us to download data, and now it's only work with Headhunter, but we plan to extend this tool. I think next data source will be through всем. Interesting approach will be to download data from, for example, US job advertisement and compare the requirements in Russian market and US market. Our hypothesis is that we have on our Russian market, we have a lack with 1 or 2 years. And if we will build educational programs based on analysis of US job market, we will prepare our students for future jobs. You can use our data sets that was used to build analysis that I showed you, and we proposed an examples of 4 educational programs for web developer, data scientist, software tester, and IT analyst. Of course, we have to do other programs. Now we are interested in software security and positions related to team leads and other leaders position. If you have any questions, you can not only ask it now, but you can contact me using this email. Thank you very much.
Thank you, Andrei. And we have questions from Natalia Populovskaya. Is it possible to use this method to solve the problem of estimating consumer demand in a particular industry?
Yes, it's possible. Actually, we need the questions is how we will be able to collect data from that particular industry, because actually our research, initially our research consisted of 2 parts. First part is related to IT specialist, and the second part is related to IT specialist that works on big plants, factories, and industry. Unfortunately, we will not be able to build ontology for the second part, because Headhunter does not have enough job advertisements. It's plenty of job advertisements for IT specialists, for software developers, but even for some IT specialists, for example, for database administrators, it's not enough data to build a good ontology and a good educational program. So if we will be able to acquire data from that industry, we will be able, actually, yeah, we need actually two types of data. First of all, we need data, and second, we need experts who can build the first version of ontology, who can say that this term and that term actually one thing. We should connect them together, and this topic is more general than that too. That 2 topics are different variation of that previous topics. If we'll be able to get data and get experts, that certainly could be done.
Thank you, Andrei.
Okay, I have another one question. Do you have any research about the dependence of salary and demand of some particular skills with time?
Actually, we have we do some research about salary. Actually, we compare salaries in various regions, and we also conducted some research for salaries related specifically to Sverdlovskaya Oblast, our own region, but unfortunately, it's not included in this paper. We have Jupyter notebooks for that topics. I'm not sure. Is it included in our repo? I will check, and I think we will, if it's interesting, we will post an example of how this data set could be used to compare prices. Because original data sets contains all data from vacancy descriptions, including salary, if job advertisements contain salary.
Okay. And my last question about the educational program for data science. So you have a table with 4 courses, and courses about SQL, data science, not IT analyst.
Oh, sorry.
It is before.
Yes,
yeah.
This one.
So foundation of SQL is the last course, or it's just enumeration, or it's just a list of courses.
Oh yes, it's a list
without
of
order.
It's not order. I think that's we should start with Python, then with SQL, or Python and SQL could be in parallel, and then of course actually it depends on the design of programs, because to be honest, SQL and data preparation, data cleaning is relatively boring topic, and students want to analyze data as soon as they can, and they try to do some interesting tasks such as image recognition, NLP tasks to create some chatbots, and only after that they have some experience, so that they need, in order to build good model, they need good data, and in order to get good data, they actually need to know, first of all, Python library, second, SQL, and how to use these technologies together. So I don't have an answer right now.
Okay. Thanks. Any other questions from the conference attendees?
So, but yes, oh, it's not SQL. Oh, okay. Nothing.
Okay. So thank you, Andrei, for a very interesting presentation. And for today, our information technology section is over. I hope everything was interesting for you, and see you tomorrow. Good luck.
Thank you very much.